Okay, ठीक है. So yeah, basically if I like revisit last class content, okay, so in last class content we did DP introduction, guys. Okay, like if I show you, that will be better. Okay, like we got to know recursive problems in recursion. In your recursive problems, wherever you are able to see problems, sub problems getting repeated, you can apply the concept of DP. The concept of DP simply says don't solve repeated sub problems again and again, rather just solve one sub problem once, and then once again when you are going to that same sub problem, just use the stored answer. Okay, so based on that we have applied like DP on 3 questions that we did last time. Okay, now in today's class, first once again we are going to just continue our DP topic, right? So first of all, though, we will start with a subset related problem, subset or subsequence related problem. Then remaining all problems are related to 2D arrays. Okay, so we will see ki how in these kind of problems you are going to understand ki what will be the dimension of DP, how you are going to work on that. Okay, so in all these questions now, let's see ki what dimension DP is required to solve my question. Right, first question is a simple subsequence based question, right? So let's see what this question is asking. Okay, now guys, it's actually a hard level question. If I tell you, it seems simple to understand this question, but in order to come up to the final logic, it's a little difficult one. Okay, so let's see how we are going to solve this one. Let's solve the hard problem for in the like beginning of the class. Uske baad all the problems are not very difficult. These problems are quite easy only. Only this one is a little difficult. Okay, so let's start what this question is asking. Given an array, find maximum subsequence sum such that no two consecutive elements are picked. Okay, first of all, though, do we all know what is the meaning of subsequence, guys? Given an array, do we all know what is the meaning of subsequence? So subsequence is same as that of subset only. Okay, in backtracking we did a question, is there any subset with some k or not, right? So I hope you remember that question in which we were applying yes or no call, like if elements of array are like this a, b, c, so suppose you are at a, you will apply either yes or no. Okay, now then next time you are at b, you will apply either yes or no. Here also yes or no. Finally you are at c and you are applying either yes or no call. So by using this simple recursion where each and every element is coming and they are just expressing feelings like come, like pick or don't pick. So with this small diagram we were able to go on all the subsequence. Okay, right? So like let me write it fairly. Like suppose if there is an array ABC, these are the elements, 0th element, the first element and the second element. Okay, so at the 0th element you have 2 options to explore. I'm just telling you in backtracking how we encountered that subset sum problem. Okay, so you have 2 options here, pick or don't pick this element. Whether you pick it or not pick it, next time you are going to go to the first element. Here also you have 2 options, pick it or don't pick it. Here also you have 2 options, pick it, don't pick it. Now next time you will go to the second index. Here also you have both your options, pick it, don't pick it, pick, don't pick, pick, don't pick, pick, don't pick. Now if you are reaching at each and every base case, so read this and understand ki all the subsequence or all the subsets for this given array are generated. Got it? Like look at this subsequence. 0 is selected, 1 is selected, 2 is selected. So this sequence is the sequence in which all the elements are getting selected, 0, 1 and 2. Look at this particular subsequence. Can you read it? Can you read it? 0 is getting selected, 1 is also getting selected, 2 is not getting selected. You know what subsequence this is? This subsequence is only AB. Correct? So do you remember we did this kind of question in your backtracking problem? So yeah, maybe that logic can help you today. So that's the reason I told you. But yeah, right now let's go back to the question. So subsequence means, see guys, in an array, if you are picking some element and leaving some other element, so that is the subsequence you are going to create. Elements not needs to be continuous when we talk about a subsequence. Okay, so you select some element and you don't select some other elements. This is how we create a subsequence. Given an array, find the maximum subsequence sum such that no 2 consecutive elements are picked. You need to consider all the subsequence, but don't consider those subsequence in which consecutive elements are getting picked. And out of all those, give us the subsequence whose sum is the maximum. Let's try building our answer. Can you tell me what will be the answer for the first test case? Yeah, for this test case, guys, what will be the answer? Tell me. Consider all the subsequents, but don't consider them which are containing consecutive elements. Okay, so look at it. See, can I say I have two options? Do you agree I have two options? I can consider 9 or 3. That will give me a sum of 12, right? The second option that I do have is just 14. A single element is also a subsequence, right? So can I say 14 is my answer? The maximum subsequent sum that I can generate is 14, right? Such that in this I'm not picking any consecutive elements, correct? If you got it, can you tell me the answer in second scenario? Once again, I can see I have two options. Exactly. 13 plus 2 will be the best option. It's giving me the maximum sum. Okay. Now, what will be the answer in the third example, guys? Yeah, please tell me. Exactly. Have a look at it. 4 plus 2 will give you 6, which is better than 3 plus 1, 4. Like 8 cannot be possible, right? Okay. Reason being 4, 3, 1, if you are trying to pick, you can't pick it. You are picking consecutive elements, which is not allowed. Okay. Correct. Guys, please. You need to create only those subsequence in which no consecutive elements are getting picked. Correct? So, you should not pick consecutive elements. Okay, Mukul? How can you select all, right? So, here, either you have this option 4, 2. That is giving you as answer 6. And 3, 1 is giving you 4. So, I think 6 is better. 6 is the best we can generate. Now, coming to the next example, guys. Can you tell me what is the answer? Maximum subsequence sum such that no two consecutive elements are getting picked. Yeah, what is the answer? See, guys, do you agree empty subsequence is also a subsequence? Do all of you agree? Just select none of the element. That is also a subsequence, right? So just do that. Don't you think your best possible answer here is 0? The subsequence which shows blank. 0 is better than any negative value. Correct? So that's why my answer is going to be 0 in this case. Now, guys, till this moment, are you having a feeling that I am just considering either all the odd index elements sum, or I am considering all the even index, alternating index we need to check? Do you agree on that? We just need to check alternative index, like here 0, 2. Is this sum better than this sum or not? Something like this, okay? Like in this case, 0th index plus 2nd index or this combination. So seems like till now all the examples are directing me towards this solution. I'm just going to create alternative sum. One sum of all the even indexes, another sum of all the odd indexes, and the answer that is giving me best value, that will be my answer. Okay. So what do you feel around it? Alternating sum, if I create alternating sum, is that going to work? Okay. Yeah, still now that it feels like, yeah, it will work. But just have a look at the next example. You'll realize is it a correct solution or not. Okay. So have a look at the next example, guys. Okay. So please understand, if you are considering alternating sum, so the two possibilities that you will get is 9 plus 13, that's a 22, right? The second possibility that you will be getting is a 28. You will say my answer is 28, and tell me, is your answer 28? Is the maximum sum subsequence that you can create is 28? No, it's 33. Why don't you select 9 and 24? That is also a subsequence, right? And that is also not containing any consecutive elements. So all of you agreed on this point, alternating sum trick is not going to work. Okay. So if you are feeling about alternative sum trick will work, it won't work, guys. It's not an easy problem. So this trick is not going to work. Like here you can see your answer is coming out due to the subsequence 9 and 24. Okay. So your best possible answer is 33 here. Got it, guys? So here your answer was the subsequence containing just 14 in it. In next case, your answer was 13 plus 2. In the next case, your answer was 4 plus 2. In the next list, just pick nothing so that your answer will remain at least 0. And last but not the least, in the last case, your answer is 9 plus 24. That is 13. Okay. The answer in this case can be 7. How? Now, Sunil. See. Maximum subsequence sum such that no two consecutive elements are picked. You are not allowed to pick consecutive elements to build your subsequence. Okay, right? So that's why this is a subsequence. Okay, guys, once again, please this question is not about maximum subsequence sum. There is another line also associated to it. You know why? See guys, will I ask you this question kya? After that backtracking class, will I ask you this question? No. You know why? Because if you know how to check if there is a subset with some key or not, you can definitely do this question. You'll just keep a max variable, and out of all the subset sums you are creating, you will just construct the maximum sum, correct? There is another line in this question, and that is what is important, okay? So find maximum subsequence sum, but the subsequence that you are going to consider should not contain consecutive elements in it. Make sense? Like here, my answer is 14. Otherwise, I could have just picked all the positive elements and created the best answer, right? My answer is 14 because if I am picking 14, I can neither pick this one, I cannot pick this one. So answer is just 14. In the next case, my answer is 13 plus 2. Okay, so that is 15. In the next case, my answer is 4 plus 2, that is 6. In the next case, my answer is 0. So till now, a lot of people will think, let's find alternative sum, and that is what will help us in our question. Okay, let's find sum of all the even indexes, and then let's find sum of all the odd indexes, and let's see which one is giving us a better value. But that is not the truth, guys. It's not like always you need to pick alternating sum. Okay, it's not like that. Like next example is a reason why the alternating sum trick won't work. Reason being, you are not picking alternative elements here. You skipped both of them because 9 plus 24 is giving you the best sum. Correct, guys? Make sense? So is the question making sense to all of us? What we need to do? So maximum sum subsequence such that you are not considering those subsequence which are having consecutive elements. Okay. So maximum subsequence sum such that no two consecutive elements are picked in that subsequence. Okay. So thumbs up if the question is clear. Are we clear around the question? Problem statement clear to us? What the question is asking? Okay. Last but not the least example. Let me just write that as well, just to confirm that we all are getting the question or not, because first of all it's important to understand problem. Okay, so let's see just the last example, guys. Let's see. -2 7 1 yeah, guys, please tell me what will be the answer. Maximum sum subsequence such that no consecutive elements are getting picked. Okay, so please consider only those subsequence in which no consecutive elements are getting picked. What will be the answer? Exactly. So do you agree? 10 alone will be your answer. Correct? Okay, so 10 alone, because if 10 you are including, you can't include 7 and 2 then. The only option that you have is -2, but would you like to include it? No, this is even decreasing your sum. So 10 is the answer. Correct? Right, but understand, guys, if this value is something positive, do you agree? Now your answer is 12 kind of, right? So right now, so based on the example, I'll write my answer is 10, and that is due to just this value. Correct? Okay, now guys, tell me, can we just do it just for the sake of solving this question? Can we solve this question? No matter efficiently or not, can we just solve it, whether on the, like, whatever we have learned in the backtracking class? Okay, so see, the only thing is you should know how to find out all the subsequence, and if you know that, you can just do this question with brute force approach. Okay, so I'll just write the brute force idea. We're not going to solve it, but I'll suggest you if you want to do it. So please, idea 1 is simple, my brute force idea. Okay, so the brute force idea is find all subsequence, or I can say go on all the subsequence. Yeah, I can say create all subsequence, something like this. So create all subsequence now on reaching base case. Based on the backtracking class, guys, in each and every base case we were hitting a particular subsequence. Okay, so on reaching base case, check if the subsequence is containing any consecutive elements or not. Okay, so check if the subsequence is containing any consecutive elements or not. If it is not containing, consecutive element, we can consider it for our overall best answer. We can consider its sum to find overall best answer. Okay guys, now I would like to give you some insight around this idea, so that if you are willing to do this, I'll just tell you the TC also. So if you are willing to do this, please go ahead. That will just be a good practice thing. Okay, so just construct all the subsequence. Now once you have reached the base case, see if that subsequence is containing consecutive elements or not. If it is not containing consecutive elements, so this subsequence sum can be your answer. You just compare it with the overall best answer that you have. Okay, now please understand how my approach is going to work. Let me first of all show you how do you construct all the subsequence. See guys, this time it's important that you are constructing the particular subsequence, so that you know if it is containing consecutive elements or not. So I'll just give you some idea around it. Okay, right. So see guys, I'll suggest you, suppose these are your elements A, B, C. I'll suggest you creating a Boolean array of same length. Understanding why I am suggesting you to creating a Boolean array of same length? Reason being, this is nothing but your subsequence. Okay, so whenever you pick a particular element, just tick mark here, otherwise don't tick mark. Let me show you what is my purpose around this. Okay, so see, when you're at the 0th element, you have two options, whether to pick it or ignore it. Correct? Now next time you will reach 1th index, you have two options, pick, ignore. Here also you have two options, pick this element or ignore this element. Now next time you are reaching the 2nd index, and from these also you have two of the options, pick, ignore, pick, ignore, pick, ignore, last but not the least, pick, ignore. Okay, now I will show you something. Right? Okay. Now guys, please understand, when you are making a yes call na, just to pick that element, so in your subsequence just put true in front of that, like 0. When you are making a yes call, just before that go at the 0th index and put a tick mark here ki yeah, I am picking you. Now when you will reach here, if I show you, when you will reach here 1, like see, it's like that ki yes call you are making, so before that in the subsequence array you need to put a true there. So it's like that ki, so that once you reach the base case, you know this information ki 0th got picked, 1 got picked, 2 got picked. Okay, so here when you are here, all things here should be TTT. Now guys, when you are here, this is a base case, check ki are you containing some consecutive elements or not. You are containing them, so this subsequence sum cannot be your answer. Am I right? Okay, next time when you are coming here, your information should be like this ki 0th got picked, 1 got picked, 2 is not getting picked. Now once again you will check ki are you containing some consecutive elements or not. It's containing, 0 and 1 are getting picked. That means this can also be not your answer. Okay, next time, suppose you are here guys, can you tell me first of all what should be the state? So do you agree 0th element is getting picked, or 1 is not getting picked, 2 is getting picked? So your array should be something like this. Got it? Like this single array is the information ki are we picking the element or not. Got the point? Okay, now once you are reaching the base case here, the subsequence is 0 got picked, 1 didn't get picked, 2 is getting picked. Now tell me guys, can you consider this particular subsequence sum in creating your overall best answer? Can this subsequence sum can be your valid answer? The answer is yes. You know why? You are not picking any consecutive elements here. Correct? Consecutive elements are not getting picked. Make sense? So this is an exercise that you can try. For this exercise, you should definitely solve that question first, which we did in the backtracking problem, ki how to check if there is a subset with k sum or not. Okay, so I just gave you a hint ki how you can keep a track of the entire subset that you have created till now. You can take help of a Boolean array. Whenever you are saying yes ki yeah, ith element wants to get picked, before that yes call, at the ith index put a 2 and then make the call to next point. Okay, if you are not picking your ith element there, So please put false there. Okay, so it's like there. It's like that. Okay, so I think you can try it if you want to, but if I tell you the TC, you will definitely feel that this is not going to worthy enough. Can you tell me what is going to be the overall TC for this code? So see guys, definitely 2 power n, you are just creating all the subsequence, but in the base case, you are making one more traversal to check if that subsequence is containing consecutive elements or not. It is even more than 2 power n. It's something like 2 power n into n. Agreed? Correct? Reason being 2 power n definitely, because you are creating all the subsequence. Right? Second thing, once you have created all the subsequence, in base case also that's not just an O1 thing. Once you are coming to base case, you are checking this entire array. Are you containing consecutive elements or not? So this approach is going to take 2 power n into n if you are just writing recursion here. Got the point? Now, first of all, that's just a to do. Create all the subsequence. In the base case, check if the subsequence is containing consecutive elements or not. If it is not containing, you can consider this subsequent sum as one of the answer. Maybe that can be best of the answer. Okay. Now guys, first of all, though, we are not going to do this question like in this way. Okay. Right? This is just an exercise. We will try not to create invalid subsequence. Like in this approach, you are creating all the possible subsequence, no matter if there are consecutive elements or not, you are creating all the possible subsequence. In the next approach, in the idea number 2, I will try to construct only valid subsequences. Okay, so let's try to think about idea number 2. Optimization. Can we optimize it? Can we just construct only the valid things rather than, yeah, exactly, Pratik, yeah. So rather than doing our work in this way, can we just go to valid subsequence, the subsequence that are not containing consecutive elements in it? So the answer is yes, you can, but you just need to think about the logic. Okay, so see guys, let's try to think about it. Okay, so 0th element, first element, second element, third element. Suppose this is given to you. Now understand, suppose this is an array. Now guys, see, doesn't matter if you are starting from the 0th index or you start your work from the 3rd index, it does not matter at all. The point here I want to explain is that you should be comfortable with both of the things. Okay, so see, this time I'll do it a little differently. Suppose I'm here to calculate the answer of 0 to 3. I want to take decision based on 3rd index. Okay, I have two options, whether to pick it or not pick it. So let me explore both of my options, whether to pick this 3rd index element or to not pick this 3rd index element. Okay, my question to you is, let me ask you an easier one first. If I am not picking the 3rd index element, can you tell me what is the remaining problem that I should find answer for? This 3rd index element is not getting picked. So what is the remaining problem that I need, like for which I need the answer now from the recursion? Okay, so do you agree that is nothing but the answer of 0 to 2? You are not picking this element, so you can just grab the answer of 0 to 2, correct? So yeah, my sub problem here is going to be 0 to 2. Very nice. Beautiful thing is, if you have decided that you are going to pick the 3rd index element, can you tell me what is your sub problem now? If you are deciding that you are picking the 3rd index element, you are picking this one. So what is your sub problem now? Is your sub problem once again 0 to 2? No. No. This time your sub problem is not 0 to 2. Because in the sub problem 0 to 2, 2th index can be included. So do you agree that should be this part only? Leave this spot. Leave this spot. Correct? So now I am directly going to make the call to 0, 1. The point is, whatever answer is coming from 0, 1, to that I am going to add this 3rd index element, because I decided that 3rd index you are going to be picked. Okay, but we'll think about it later. So whatever answer is coming from here, in that I am going to add array of 3. That's why I am highlighting it with a different color. Okay, right. Now let's think about it. You are at 0, 1. You are at 0, 1. Smita, see, if you are picking the 3rd index element, where are you making the call? To find the answer of 0, 1. Now the call of 0, 1 can never include the 2nd index element, right? Okay, so this is the thing. Like whenever you're picking an element, now you are just directly making a call to like here. Like let me show you once again this part, guys. See, I have two options. I'm here to find the answer of 0, 0 to 3. Now the elements, the target element that I'm choosing right now is third index, although you can go with 0 also, but right now I want you to show this in a reverse direction. Okay. Now my question is at third index. The point here is I have two options. If I am not picking the third index element, I can get the answer of 0 to 2. Because third index element is not getting picked. I don't have to worry about the consecutive part right now. Okay. So I'll just make a call to 0, 2. Perfect. But the point is, if I am deciding to pick the third index element, I am not making a call to 0, 2. I am making a call to 0, 1 instead. Correct? So 0, 1 answer can never ever include this element. That means whatever answer you are getting from here plus your array of 3, because you decided to get the answer of array of 3, correct? And see, Smita, when you are making a call to 0, 1, same thing is going to be applied there. Both of them are not going to be picked. Only one of them will get picked. Understanding it? Okay. So that's why I'm saying, yeah, if you are picking the third element, your call has to be 0, 1 now. Okay. And whatever you are getting from here to that, don't forget to, like suppose you are getting something from here. So to that, you need to add array of 3. Correct? Okay. Now let's try on doing the calls a little ahead. Let's see how the values are going to come. 0, 1. See guys, we are here to find the answer of 0, 1. The element that you want to decide right now is 1th index element. Okay. Yeah. Every time in every subsequence problem, guys, there will be only two possibilities: pick or not pick, pick or not pick. Okay. Right. Now here also, please tell me, please, this is going to be very important. I am picking the 1th element. I am not picking the 1th element. Okay. So see, I am here to find the answer of 0, 1. When I am not picking the 1th element, can you tell me where should I make the call? Yeah, I should make the call to find the answer of 0, 0. Okay. So I'll just make the call to find the answer of 0, 0, because I don't have to worry about the consecutive part right now. Okay. Now guys, when I am picking the 1th element, yeah, I am here to find out the answer. I am deciding ki let's pick the 1th element. Now, what should be my call? Can I make the call to find the answer of 0, 0? No, I can't. Because 0, 0 call might include 0th element also, and you are including 1 as well. So when you are picking the 1th element, the call is going to be made where? See, 1, like just skip one left hand index of that. So that's going to be 0, -1 directly, to be honest. That will be 0, -1. Correct? Okay. Now very important. Here though we have reached the base case because one invalid index is coming. Okay. Now let's try to understand. Important thing here. 0, 0. What do you feel? Should I always return, like when I am here to find the answer of 0, 0, should I always return the array 0 value from here, or I need to think here as well? Can I always return array of 0 from here? Like, okay, let's return whatever is array of 0. Okay, so understand this point, guys. It's not important if from this call you are going to return array of 0. You know why? Please understand. See, I'll just show you a small option. Okay. If it is -2, guys, imagine if the array of 0th value is -2. Now, don't you think here also you have two options? To pick the 0th element and to not pick it. And do you agree? When you don't pick the 0th element, that's a better situation. Correct or not? Okay. So please, when you're asking the answer of 0, 0, don't just return the 0th value. Here also explore both of the options, to pick or not to pick. Because in some situations, picking it may be a better situation, like this, when the value is positive. Otherwise, in this situation, maybe not picking is the better option. Okay. So I know, yeah, little confusion is there, but trust me guys, once we do this thing, once we write the logic around it, the main logic around it, you'll get it ki how the subsequence are getting created, how only the valid subsequence are getting created. In this question, I'll suggest you keep your entire focus on the recursion. Forget about DP for a moment. Okay, so keep your entire focus on recursion. Once you understand recursion, writing the DP code is not going to be difficult. Okay, so here I want to cut this part right now, because I'll give you a proper dry run ki how exactly your logic is working. I will just talk about only a small thing. Okay, suppose I'm going to make the helper call by passing this array, and this time I'm going to start with the third index, guys. So I'm passing n-1, right? Okay. Yeah, Pratik, that's why I said ki see Pratik Mukul, don't worry about the complete thing. I cannot show you the complete thing right now. After writing some pieces of code, you will get it automatically how things are working. Okay. Right now, let's just think high level, guys. If we go a lot in the low level right now, we'll not understand this. Okay. Right now, just tell me one thing. Suppose I'm here to find out maximum subsequence I. I'm here to find out the ith index answer. Okay, what is the answer? Till ith index. Okay, that means 0 to I. What is the answer? I have two options, whether to pick this ith element or don't pick it. Okay. So do you agree, when I am not picking the ith element, my call is going to be what we have decided, guys? When you are not picking this ith element, your call is going to be nothing but whatever is the answer till I minus 1. Okay. So we are going to make the call to ms of I minus 1. Right? Okay. Now when you are picking this ith element, suppose you are picking this ith element. So what we have decided? My call is going to be the answer of not I minus 1. The answer of I minus 2 instead. What is the answer till I minus 2? Okay. So what is the answer till I minus 2? Now the point is, here suppose this answer I am storing it in a variable A, and this answer suppose I am storing it in a variable B. Can you tell me here which two things should get complete? What is going to be the answer till ith index? I got the answer from both of my calls. What should be the answer till ith index? Okay, please tell me. So see, can I say that answer is going to be nothing but maximum of A comma B? Do you agree, or am I missing something? Is the answer going to be just A comma B, maximum of A comma B, or am I missing something? So see, you were here at the ith index. You said if I pick the ith element, I am going to make a call to find the answer of I minus 2. What is the answer till I minus 2? So what is the decision you are taking? You picked the ith element. So don't you think whatever is the answer till now, to that it's important that you add yourself? Correct? Because you have decided to pick the ith element. So don't you agree? The complete answer is not just A. It's A plus array of I. Okay, because in this call you are saying I am getting picked. Right? Now, here in this call, what are you saying? If I don't want myself to get picked, you are finding out the answer of 0, 2. Tell me, guys, if the answer of 0, 2 is B, can I say the competing candidate here is just B? Correct? So you have two candidates, A plus array of I and B. Got it? The answer till I minus 2 plus me, and the answer till I minus 1 if I am not getting picked. Got it? Once again, please revisit this thing, because this is going to be my entire high level. Based on the high level, then I will think what is the low level. But right now, though, keep your entire focus in the high level code. Okay, see. I want to find the answer till ith index. Suppose I am here. So I have two options. I am getting picked. So if you are getting picked, then you can't make a call to I minus 1 because you don't want consecutive elements to come. So that is why you are saying ki, please find the answer till I minus 2. Okay. Now, whatever is the answer till I minus 2, consider that in a variable A. So, your answer is going to be this A plus yourself because you decided to get picked. So, that is why this is what I am writing here. Right? Now, what is the next option? If you are not getting picked, so please find out the answer till I minus 1. If that answer is B, so this is the next candidate that you have. Correct? So, I think based on this thing, we will get our answer. Now, my next thing is going to be, let's write our code based on this high level thinking. Okay. And then we will see how this code is really going on the subsequence and giving me the answer. Okay, so let's try writing the code first. Sometimes, especially in recursion, it's important that you break down your thinking process in two parts. Just think about the calls first. The faith thing, if I am depending on these sub-problems, I'll be able to get my answer. And then in the next part, think about the Dragon. Okay, so int, I am naming it as maximum sum subarray, or I can just name it as solve right now too. See guys, in the assignment problem though, you will be just receiving the array, okay, and then you are going to make the call to helper function, and to the helper function what are you providing? The array. And then basically you will just return whatever answer it is saying you to return. Okay, So helper comma a comma n minus 1, because this time we have decided to start with a minus 1. Start with the last index. Okay, so whatever this helper is returning, I am just going to return that. So this is what I'll write in the assignment. Pratik, see, we will not be doing it in the way we did the backtracking. This is, we need to somehow convert it into DP, subproblems returning the answer. So are you getting it? We are not doing it in the way that we did the backtracking problem. Got the point? Okay. So we are like, you can see your helper is returning the answer. Like whatever is the best out of them, I'm going to return that answer. You are saying na ki this call will give you A, this call will give you B. So that is a different process. This one was a different. You were creating your answer and going from bottom to like, in this direction. Backtracking was a little different. This time we are thinking in a different manner. Okay. Because at the end we need to convert this logic into DP as well. Okay. Now int helper. In the helper function we have two things, array and the index that I am talking about. Okay, it's now simple things. Here I have two options. First of all, if I am picking the ith element, then I am going to make the call to directly to the I minus 2 index. Okay, so helper, please give me the answer till I minus second index. Okay, so this is when you are saying ith is getting picked, ith element, getting picked. Okay, right? So this is your yes kind of call. Or let's right now, so let's write it in a simple manner only. Then I'll write okay, helper a comma I minus 2. So this is a call when you are saying ith element getting picked. Okay, getting picked. Now the next call, when you don't want the ith element to get picked. So see guys, if ith element is not getting picked, the call that you are going to make will be to I minus 1. Correct? Okay. And this is when your ith element is not getting picked. Now simple strategy, what is the answer? The answer that you have is nothing but math.maximum of a plus yourself, because in this you are saying ith element is getting picked. So give me the answer till I minus 2, and to that I will add myself. And the next candidate that you are having is B. And finally you are just returning this answer. Good guys, that's it. This is what the logic is. Simple. Okay. Now the only thing is dealing with the base case. Can you tell me what will be the base case? See, this time, please tell me what will be the base case, guys. Okay. What's going to be base case? Okay. Dekho, the small diagram that I created. Suppose you start your working from the, suppose there are only 3 elements, 0, 1, 2. This time you are starting your work from the second index, the last index 2. If you are picking it, the call you are making to the 0th index. If you are not picking it, the call you are making to the first index. You should not stop till the 0th index. This is what we have decided. You should not stop at the 0th index. You can, but then you need to write another check if it is a positive element or not. I'll suggest you, don't stop at the 0th index. Make a call. If you are picking it, you are going to make a call to 2 lesser. If you are not picking it, you are making a call to 1 lesser. So simply guys, can I say, when your I value is becoming negative, that is from where you should return a 0 value. Correct? So don't stop at the 0th index, because you don't know ki at the 0th index, what is the better choice, to pick it or to not pick it. Because sometimes when this value is negative, you don't want to pick it. If it is positive, you want to pick it. So that's a case dependent thing. So I'll suggest you not to stop at the 0th index. That's why I'm saying ki stop at the one step after it. Okay. So when your I value is becoming negative, there is nothing there. So you can return a 0 value. This problem is sum related. So when there is nothing, you can return a 0 thing. So this is the logic, guys. Simple and sweet. Like this looks like a very small code, but trust me, it's doing a magical thing. Okay. Right. So this is the code. Now we will understand the pure recursion around it. How this recursion is working. Once we are comfortable with the recursion, then at the last step I'll apply DP. Trust me, applying DP is not more than a 2-minute task in this question. Once you understand the recursion, everything is done. Okay, so now I will make you understand how recursion is working. Okay, so I'll try to create a beautiful example, and then with the help of that we'll try to understand this. Okay guys, and I'll try we can do it here only. Okay, yeah, let's try doing it. Just a second, I'll just arrange it a little bit so that we are getting enough space. I'll create a very beautiful example for you. Mukul, you can start your working from 0th index. I'm just making you comfortable ki your work can be done from anywhere. Okay? You can start your work from 0. Of course, if you're starting your work from 0, you need to change the way you are making calls. But you can start your work from last index as well. Both of them are same, kind of. Okay? Right? There is no particular reason for that. Both of the things are fine. Okay? No, yeah, Pratik, we are not applying anything separately for negative. Don't worry about negative, guys. I'm going to take example in this, which is including the negative elements. So 2 minus 7, 5, and let's not make it 5, let's make it 3 and 5. Please tell me, guys, what is the answer in this case? Yeah, negative I. Yeah, exactly, Dharmesh. I wrote my code based on the thinking ki I'm starting from the last index. Then only I'm making call to the lefter index of my cells, right? Okay. Okay, so the answer is going to be 2 plus 5, right? Now, guys, I have just one question. What will be the answer till first index? Can anyone guess it? What will be the answer till first index? That's going to be what? Exactly, that's going to be 2. Minus 7 should get ignored here. Correct. And trust me, if the scenario is just opposite like this, suppose this is the scenario, okay, don't worry, you will still get fine things. Okay, so I will just explain you on this example. Any example that is coming to your mind, you also try on that, but I'll explain you. Once you understand the working now, you'll get it how it's going to work on each and every example. So 0th index, first index, second index, third index. Let's start our working, guys. Okay, let's see. Please focus on the recursion now. We are going to start making our call from which index? I'm going to start my call from third index, key ms of 3. Okay, now what I'll do, here I have two options. The first option is to pick this, and the next option is to not pick this. Okay, when I'm picking this, first of all, guys, I'll draw the complete recursion diagram, then I'll run it. Okay, when I'm picking this, do you agree the call that I'm making is to I minus 2? So do you agree that I'm making the call directly to the first index now, right? And when I'm not picking it, I'm making the call to I minus 1. That means to the index second only. Correct? From here also you are going to make both of the calls, right? So you'll make both of the calls, to pick it or to not pick it, right? When you are picking this, so you are making a call to two lesser thing, that means ms of minus 1, correct? And when you are not picking it, you are making a call to ms of 0, right? So here you should stop because index has become negative. That's a base case. Here you should not stop, and there is a reason behind that. Now from here also you'll make two calls, whether to pick this 0th element and whether not to pick it. If you pick this 0th element, do you agree you are going to make the call to second minus 2? And if you don't pick this, you are making a call to I minus 1. That means 0 minus 1. That's just a negative of minus 1. Minus of 1. Correct? Now guys, both of them are base cases. Now I should stop. Okay. Now here also what should I do? ms of 2. I am at ms of 2. So I have two options, whether to pick this element or not to pick it. Okay. You tell me, if I am picking this element, what should be my call? If you are picking the second element, what should be your call? Okay. Your call should be to the index I minus 2. If you pick this ith element, your call should be to I minus 2. That means, do you agree it has to be ms of 0 then? Correct. And if you are not picking this element, your call has to be 1 lesser. That means ms of 1. Okay. Correct. Now what I'll do, first of all, though, this diagram ko by looking at the code, we have almost created it. So I'm going to shift it to the next page. and the important lines are these only. Once you are getting A, B, so how you are creating the answer, that's it. So this is the important lines that I grab out from the above code. Okay. Now guys, here the diagram is not yet completed. I'll draw it nicely and then we will think about the answer step. One more thing, I'll just grab out the array that we had. This is the array. Now please guys, see, the recursion is not done completely. We are still not at the base case everywhere. So here, ms of 0, you have two options, whether to pick this element or not to pick it. If you are picking this element, your call is going to be ms of -2. If you are not picking it, your call is going to be ms of -1. Here guys, I will not do a lot of hard work. Do you know why? Do you all agree that whatever answer is getting returned from here, the same has to return from here as well? So what I feel like right now, what I am feeling is, let me draw it in this manner. As I'll just draw it in dash dash. Yeah, there is a recursion ahead of it, but I don't bother showing it to you because these problems are the problems that already have encountered. So yeah, we can imagine the same answer will get returned once again. Correct guys? Okay. So right now I want to focus on this recursion that I wrote, and please help me creating my answer. Okay. So see how things are going to work. You'll make a call from here, make a call from here. Now this is going to return what guys? It's a base case, and base case, whenever I is negative, base cases are always returning you 0, correct? So do you agree at this level, the A value is 0 and the B value is the right call that you are making here. Now from here, this is the most important moment, please understand. You are here to find the answer till 0th index. Left call is giving you 0 and right call is also giving you 0. Now guys, how do you compare your answers? You are saying ki A plus array of I plus B. So please understand, to this A, you are adding yourself, array of 0, that means 2. Now tell me guys, which one is better? Is this value better, 0 plus 2, or 0 is better? So 0 plus 2 is better. That's why you are going to return a 2 from here. Correct? You will say the answer till 0th index is 2. Reason being, 0 plus 2 is better than 0. But imagine just the opposite scenario. Imagine if this value was -2. Now do you believe me? When you are getting from the left hand side, you are getting a 0. From the right hand side, you are getting a 0. Now the comparison is this. A plus array of I, that means A plus your value and the 0. Do you agree? What is getting returned now? If this value is negative, so what will be your answer till the 0th index? That's a 0. Exactly. So do you agree? We should not stop at the 0th index. We should make call from there because it can or cannot pick the 0th index value. That's totally a case dependent thing. So right now, based on the case that I do have, so yeah, we are going to return a 2 from here. And that 2 is gonna store here. The 2 will get stored here. Now guys, you are at the first index. You are finding the answer till first index. See how brilliantly it will do things for you. Okay. Left hand side answer is 0. Right hand side answer is 2. So to this left hand side answer, please add yourself the first index value. That's a -7. And now tell me guys, which one will you return? So do you want to return -7 or do you want to return 2? Exactly. You are returning the best out of them. Now imagine if this value instead of -7, if it is 7, do you agree? Now you would be returning 7 only. The answer till first index, you would be returning 7 only. Okay. So can I say ki both of the things will get manifest right now though, as this value is -7. So yeah, picking myself is not a better decision because if you pick me, you are getting -7. Picking not me is a better decision because if you don't pick me, then you are getting a 2 at least. So yeah, whatever the best you are getting, just return it back. So you have returned 2 from this and that 2 is going to be stored as A is equals to 2 here. Correct? Now let's try to make the right call. B is equals to, let's try to make the right call. We will come here. Now this is guys C. Once again you are making a call to find the answer till 0th index. Previously the answer till 0th index was 2. So this time also the function call, I believe it's going to return me the same answer, that's 2. Okay, so A, 2. Correct. Now here you are making a call to 1th index. Previously the 1th index returned you what? 2 value. Correct? And this time also I believe this is also going to return me 2. B, 2. Now guys, see how the comparison will happen. 2 plus yourself. Yourself means array of 2. That means 3. Or just 2. Tell me guys, which one is better? is this value better or this value better? So 2 plus 3 or 2? Of course 2 plus 3 is better, and trust it. Do you agree the answer till second index has really, it has to be 2 plus 3. Correct? It has to be 2 plus 3. Perfect. So it's returning you that. So it's returning you 5. Now guys, the final judgment situation. Okay. The final judgment situation is this. I got the left hand side answer. That means like you were here. So you decided when you are picking this element, you made the call to this. It's returning you 2. Now, either 2 plus 5 is a better answer because this call is returning you a 2 only. Correct? Or other option is, if you are not picking this element, then whatever is the answer till now, that is your answer. So this is the judgment factor. Left call is returning me 2, right is returning me 5. To the left call, as this is a call when I include myself, so I should add me, that means array of 3, that means of 5. And this is just 5. Tell me which one is better. Of course 2 plus 5 is better, so the final thing you are returning is a 7. Correct? You are returning 7 as the answer. Select me, and whatever is the answer till now, that's a better situation. 2 plus 5 is better as compared to when you don't select me and you ask the answer for this part. Correct? So the final thing you are returning is 7. Now, first of all though, we are getting correct answer here, but you tell me guys, are you believing it that no matter whatever the case is, you will always get your best answer? Got the point? No matter whatever this case, if you explore this diagram carefully, you'll got to know that at each and every moment you are taking a correct decision only and then returning your answer. Got the point? Okay. So I think if you try run it on any example, it is going to work because you are picking your things smartly. Whatever is best, you are going towards it. You are just, using that in creating your answer. Correct? Okay. Now, once you have realized this thing, once the recursion part is clear, like Ayush, then you need to manage some Boolean array or something like array list in which you are storing the index. It's going to be a little tough process, but yeah, we can manage it. Okay, you need to create an array list kind of thing then, if you want to store indexes. Okay, right? But yeah, that's manageable. Okay, so now the next thing is, okay, recursion is done. I think we have wrote the recursion very nicely. The recursive code is done. Now I don't need this code. So dry run, we did it here, and the complete code was here itself. Okay. You tell me guys, can you apply DP in this problem? Can DP, we can apply DP, right? Okay, of course we can, right? You can just see here you were asking for a problem, give me the answer till 0. Here you are asking the same problem. I skipped it also, so that I don't have to write it again. Here you are asking the answer till 1, here you are asking the same question. Correct guys? So you can apply a DP for sure. DP of what size? Yeah. So look at the problems that you are asking every time and tell me what is going to be the size of DP. Perfect. You are asking the answer till 3, answer till 1, answer till 1, answer till 2, answer till 0. These are your base cases. You don't need to consider them. Okay. See, realize it this time, guys. What's going to be the size of your DP? Is it n plus 1 or just n? Look at the problems that you are asking. Uske basis pe tell me what is the size of the DP. N plus 1 or just n? Okay. See, this time it's just n. You know why? This is an array of size 4. Will you ever ask what is the answer till 4th index? Am I right? Will you ever ask what is the answer till 4th index? No. Right? You are even starting your recursion from the n minus 1th index. Correct? Okay. Right? Exactly. No. But the correct thing is, first of all, though, let's just shift this down on the above page. Correct? Yeah, guys. The thing is, we can go ahead with the DP of size just 10. You know why? See, look at the problems also. This array is of length 4. And you are always asking what is the answer till 3? What is the answer till 2? What is the answer till 1? What is the answer till 2, 0? And these are your base cases. For the base cases, you don't have to worry a lot. Correct? Because base case, we just hit them and they will give us the answer very quickly. Okay. So that's the reason. This time our work will be doable in just a DP of size n. I'll just create a DP of the same size as that of array. Now when I'm getting the answer till 0, I'll store it here. When I'm getting the answer till 1, I'll store it here. When I'm getting the answer till 2, I'm going to store it here. Last but not the least problem. The last problem is the answer till n minus 1th index, and that is what I'm going to store here. Got it, guys? So this is how we can do it. Perfect. So I'm just going to copy this code. right? And I'll just apply dp in it, or let me just copy this entire code. Okay, so the thing we realized कि yeah, dp can be applicable, so let's apply dp. Applying dp, and that's once again we are applying memoization, guys. Okay, now I'll paste this code, and we know in order to apply dp we just need a dp array, so let's create it anywhere. I'm just going to create the dp array here. Let's me create it with a different color. So int square bracket dp, I would like to initialize it just before I make the call. So just before making the call, what I'll do, key dp, please get yourself initialized with an array of, just a second. Okay, so please dp, you are nothing but an array of size n, and guys don't forget to fill all its value with the size -1, or like a value -1, sorry. So arrays dot fill this dp comma everywhere -1. Correct. So I've initialized my dp correctly. Now what I'm going to use, I'll just use it here. So simple, 2 steps. You have created your dp. Just before returning your answer, you are here to calculate the answer till ith index. So just before returning your answer, fill the answer in dp. dp of I. Today I'm going to name my dp array as dp itself rather than storage. Both of them are good name, so you can use anything. So that's going to be answer. And very importantly, use it as well. Before making your calls, it's important that you should check if you have already solved this question or not. So if dp of I is not equals to -1, that means you have already solved what is the answer till ith index, and you can return it. Okay, so you'll just return it. Return dp of I. That's it, guys. Okay, so point is that once you have understood the recursion, then applying dp is not going to be a very big deal. Okay, main problem in dp's question is nothing but understanding the recursion, right, guys? So in this question also, like, we spend almost 1 hour to understand the recursion part, and then we apply dp in just 5 minutes. Okay, so yeah, same tactics. I have created the dp array, initialized it just before making my call, and then I'm here to calculate the answer till ith index in this helper function. So before returning my answer, I'm putting the answer till ith index, and then just before my calls, I'm using it. If the dp of I is not -1, that means it's already solved, so use it. Okay, now based on this code, can you now tell me what will be the dp's, like what will be this code's time complexity? Space complexity, as you're creating the dp array, so it's a straightforward order of n. Time complexity is how much, guys? How many distinct problems you must be solving? So have a look at your recursion and tell me how many distinct problems you must be solving. Okay, so you must be solving the answer till 0th, you must be solving the answer till 1th, you must be solving the answer till 2th, you must be not solving them again, and you must be solving the answer till the 3rd index. Do you agree that total number of distinct problems that you are solving is just n? So that means your total number of calls will also be approximately order of n only. So that's the reason TC is just order of n. Like, understand, guys, that's a very, very big improvement to that of your brute force code. It was 2 power n into n, and this logic is just order of n. Got it, guys? Make sense? Perfect. Anyone having any issues? Right? Correct. Yep, like Pratik, see, it will take a little time. First go mein to we won't understand this thing, but once you have done all topics, some questions out of each and every topic, then you can come up to the logics. Okay? Okay, guys, so now is everything clear? Like the way we discussed recursion in this problem, okay, how recursion is working and giving me the best possible answer. Okay, and finally, how we have applied DP in this question. Right? Correct? Thank you, Abhishek. Thank you. Clear, guys? Please a thumbs up if this is now clear. Like, see, subsequence problems, if you apply brute force in subsequence or subset problems, brute force is always 2 power n, because you have 2 power n subsequences. Now, obviously, it's a need in all the subsequence problem, you apply something efficient, so that you can come up to these kind of complexities. Got it? Okay, great. Now guys, after that, all the question in today's class are not going to be very difficult. They are kind of easy problems only. Okay, so let's discuss the next one. Okay, and then I will definitely give you a break, but it's good if we discuss one of the next problem at least. Okay, so see, it's a very interesting problem, right? Count the total number of ways to go from 0, 0 to n minus 1, m minus 1. Acha, you must have solved this in terms of path HHVV, HVH. Have you solved this question previously? Maybe in your contest, right? Okay. So, but this question is a little different. Contests may, they were asking you to print all the paths. So you must have used recursion backtracking kind of concept. Okay. But this time this question asking you the same thing, but in a different manner. See what it is asking. Count the total number of ways to go from 0, 0 to n minus 1, m minus 1. It's not asking you to printing the paths. It's just asking you the count. Key, what are the total ways to go from 0, 0 to your n minus 1, m minus 1. That means from top left to your bottom right. The only two ways, the only two movements allowed to you are the right. You can go from right and you can go from down. Got it, guys? Perfect. Right. Now, please tell me, for this example, what are the different ways? Yeah, cool. Okay, so see names mein there is nothing. I generally don't use a lot of names. I just tell you ki approach mein, like based on the question you need to decide things. Okay, like in that question things were a little different. In this you are here to count the number of ways. Okay, so you can apply some optimization. Right, now let's see guys. First of all, let's calculate total ways. Let me show you. See, starting from top left, we need to reach bottom right. So if I'm starting from here, right, D, D. So RRDD is one of the way. Right, down. This is one of the way. Correct. Now the other way could be this one. Can you read it? What this way is? This is right, down. Correct. So this way is right, down. Perfect. Now some more ways. Let's see. Do you agree this is also a way? And can you read it? What this way is? What this way is? So this way is right, down, right. Okay. So this way is right, down, right. Makes sense. Now there are some more ways that I will write directly without showing it to you. I'll just write directly. Like I'll just not show you all the ways here. Now I will show you some other ways. Okay. So down, right, down. That's one of the way. Down, right, down. Another way is this one. Down, right, right. Down, right. Now there is a last way also, guys. That's down, right. Down, right. Okay. So first of all, though, in this question, we just need to think about the recursion first. Okay. Yes, Smita, that's exactly same. But that question was asking you to print the ways. This question is asking you to find the count. Okay, right. So here you definitely don't need to go on all the ways to count all the ways possible. You can apply some optimization things here. Okay, so think about the recursion first. Then we will see how can you proceed in this question. Okay, so I am here to calculate total number of ways by which I can reach 0, 0 to n minus 1, m minus 1. So what's the recursion that should come in my mind? Okay, think about it. My entire purpose is reaching here. Like, do you remember the stair problem, guys? The stair problem that we did? Perfect. So in the stair problems, if you remember that stair problem we did, okay, I think we did it in DP, right? So in DP we did that stair problem. So my purpose was to reach nth stair. Okay. Now in order to reach nth stair, I used something. So can you apply that same logic? Your purpose is to reach here. Now you can reach here from which two immediate steps? Like your entire purpose is to reach here. You can reach here from which index? Yeah, Nikhil, from every point you can go to right or down. Okay, up or left. Exactly. See guys, understand this thing. Tell me, your purpose is to reach here. can I say if you find the total number of ways to reach just the top of yours, and if you find total number of ways to reach just the left of yours, you will get total number of ways so that we can reach you. Think about it. See, you are here to find total number of ways in order to reach here. What I am saying, just find out total number of ways to reach this cell, because from this cell you will be able to come up here by making a D, and find out total number of ways to reach here, because from this cell you will be able to come up here as well. Now I will show you something. See, okay, so find the total number of ways reaching here. Do you agree that's nothing but 3? Let me show you. 1, 2, and then 3. Okay, so there are 3 ways by which someone can reach here, starting from 0, 0. And now guys, do you agree, using all these 3 ways, by just making a D step from here, you can reach your destination finally? Correct? Okay, makes sense? We just need to find total number of ways reaching here. Correct? Okay, now similarly, can I say just find total number of ways reaching here? Okay, that will be what? It will be like this. Like if I show you, it will be like this, then this one, and finally, okay, let's draw it in a nicer manner. I think this one, this L shaped, then going from here till here. I think I created 2 same things, right? I think in this I created same path. Let me once again show you. See guys, see, here we are understanding the recursion part first of all. How can we get the answer of 2, 2? So the point is, I'll not show you. Here I just draw it, but what I can do, first of all, I can create a bigger matrix so that it's not creating a lot of confusion. Now I'll show you. See guys, the purpose is to reach here. Now in order to reach here finally, the thing that I can say is, in total ways, how can you reach here? Because you know what? Because see, if there are 4 ways that are helping you reaching here, imagine there are 4 ways that are helping you reaching here. So don't you agree, all those 4 ways will help you reaching your destination finally? Because from all those ways, you can just use a D step and come to the destination finally. Okay, so in order to know in how many ways you can reach here, you should just know 2 things. In total ways you can reach this spot, plus in total ways you can reach this spot. Now I'll show it to you. See, how many in how many total ways you can reach 1, 2? So let me show. This is the first way by which you can reach 1, 2. Okay, now this is the next way by which you can reach 1, 2. Okay, now the next one. This is the next way by which you can reach 1, 2. There are only 3, Pratik, correct? Not the 4th one. You are just allowed R and D, correct? So this is the first way, this is the second way, and this is the third way. There are 3 ways by which you can reach this particular cell. Now tell me guys, can all these 3 ways help you reaching your destination finally? Of course, yes. Just make a D step from here. All of them can help you reaching your destination finally. That is why I am saying if you are reaching here, you can reach up to here also using all these ways. Perfect. Similarly, find out all the ways by which you can reach this spot. So how many ways are there by which you can reach this spot? So let me show. The ways are, first this one, this L, correct? The second way, this one, this 4 kind of shape, okay, and the last but not the least, this one. If you can look at it carefully, there are 3 ways once again. Now don't you think all these 3 ways can also help you reaching your destination finally if you just take a R step from them? Do you agree guys? So my gist of the story is this. Let me write it, then I think it will make more sense. The gist of the stories is this: ways to reach I, j is nothing but equivalent to number of ways in which you can reach just the top cell of yours plus number of ways in which you can reach just the left cell of yours. That's it. This is what is going to be the relation. Perfect? Makes sense? So like here, my purpose is to come here. So I am saying just give me the total number of ways by which I can reach here. So that's a total of 3. Just give me the total number of ways by which I can reach here. Of course, starting from 0, 0. That's also a 3. That means I am saying ki to reach me there are 6 ways, and that's true. There are 6 ways to reach the n minus 1 m minus 1. Got it, guys? Then an expanded version, if I write it, so let me write it in an expanded version ki ways to reach I comma j from 0 0 is equals to ways to reach I minus 1 comma j from 0 0 plus ways to reach I comma j minus 1 from 0 0. So this is the conclusion. Perfect. Now just to confirm you this thing at each and every spot, I will just show you. Let me just confirm you this thing on each and every spot rather than just to the final destination. Okay guys, see, you are here to work with the recursion, so your logic should be correct for each and every spot rather than just to the final spot. Okay, my question, suppose right now I am here, I want to find in how many ways I can reach 0 comma 2. Okay, I am here to find in how many ways I can, or let's use another spot, in how many ways I can reach this 1 comma 1. So tell me guys, what are the 2 spots on which you are making call? I am here to find out in how many ways I can reach 1 comma 1. So what are the 2 steps? You are making a call to the above cell, correct, and you are making a call to the left cell. Perfect. Now you tell me one thing, in how many ways you can reach here guys? Can I say in only a single way? Perfect. Here you can reach by using only a single way, and that's like this way only, R. And in how many ways you can reach this spot? Can I say that is also only a single one? So do you agree here you can reach by using 2 ways? Those 2 ways are via this one and via this one, correct? You can reach 1 comma 1 from 0 comma 0 by using 2 ways, 1 plus 1. Makes sense guys? Okay, so this is the point. Here you will write 2, then I can reach this spot using 2 ways. Similarly, you tell me, first of all, can anyone tell me in how many ways we can reach this spot 0 comma 2? In how many ways you can reach this? Do you agree there is only a single way, that is RR? Okay na? RR, that's only the single way of reaching this spot. Now guys, trust me, here when I am finding the answer, suppose I am here one day, I want to find in how many ways I can reach 1 comma 2. So do you agree you are going to make a top call that will give you its answer? From 0 comma 0 to me there is only a single way, and then you will make a left call that will give you 2 answer. From 0 comma 0 to me there are 2 ways. Do you agree? Now you will be able to calculate your 3 ways. There are 3 ways by which we can come up to you. Make sense guys? Okay, so this is how the process is going to work. Perfect. Okay, so is the relation making sense? At the end my target is to come here. Starting from 0 comma 0, my target is to come here. So I am just solving my problem with the help of some sub problems. I asked in how many ways you can reach here. So if there are 3 ways by which you can reach this spot, that means all 3 ways can help you reaching here as well. Similarly, in how many ways you can reach here? So if there are 3 ways reaching here, those 3 ways can also help you reaching here. So simple. In how many ways you can reach here? Total number of ways reaching this spot from 0 0 plus total number of ways reaching this spot from 0 0. That is the total number of ways by which we can reach here. What the point guys? So is the relation making sense? Perfect. Anyone having any issues regarding the relation part? Can we just write down the recursion and let's see are we getting the correct answer or not? Okay, so recursion mein I just need to write this statement guys. Perfect. So let's write the recursion and then with the dry run we will see if there is any issue or not. Okay, so right now though I'll just make the call, but okay, let's write the solve function also. In assignment how the problem will be given. Okay, think about it guys, take your time. Do you even need a matrix to solve this question? Do you need a 2D matrix to solve this question? Think about it. You are here to return total ways. Okay, take your time. Do you need a matrix to solve this question? Because even if you need assignment mein, you are just given n and m. Now you tell me why they are not providing you the matrix, or do you want to create it from your side? See guys, the point is I draw this matrix just to help you understand how are you finding the ways. To be honest, that's not needed. Are you using any value of this matrix? Yeah, you should create a matrix only when the values inside that are helping you. Tell me, are you using any value present at any index in this matrix? You are not. So that means this is not needed. And neither you are putting any data here. So nor you are retrieving the data, nor you are fitting the data. That means that storage is not needed. I am just drawing the way so that I can explain you the problem. Matrix is not needed. Okay. Okay. This one in this question, matrix is not needed. If you didn't get it, no worries. I'll explain you why that's not needed. Index ka game hai. It's all about the indexes. Okay. Now let's start. We are receiving N and M. So what will we do? Let's return helper. Whatever this helper is returning. And initially I'm going to pass it n minus 1 comma m minus 1 at ij. Give me the total number of ways reaching here. Give me the total number of ways of reaching n minus 1 m minus 1. Now let's go write the helper code. So int helper int n comma int m, or let's write it as ij, because in my relation I have used ij. So simple. You are here to find out total number of ways reaching ij. So you will just simply say, give me the total number of ways reaching just above me. Okay. Mukul, that's a different question. That's a question with a blockage. That's our next question. This question is without any blockage. Okay. Right. You'll get the difference. Let's solve the next one. Then you'll get the difference what I'm saying. Okay, guys. So you will just simply say, in order to reach I comma j, please give me the total number of ways by which you can reach just the top cell of mine. So that means give me the total ways of reaching I minus 1 comma j, and similarly give me the total ways of reaching just the left cell of mine. That means I comma j minus 1. Beautiful. And then what is your answer, guys? Please quickly tell me what is your answer. In how many ways we can reach I comma j? So that's nothing but summation of the above two things. Okay, right? So that's a plus b. Simple. Now guys, base case. What will be the base case? You are blindly making calls, to be honest. You're blindly making calls, right? From everywhere you are making two calls. One call to the above cell of yours and one call to the left cell of yours. Are you confident that every time there will be a top of yours and left of yours? Yeah, you are not confident. Like sitting here, you can't say ki ha, there is a valid top of mine. Sitting here, you can't say there is a valid left of yours. Correct? So you can go on those invalid spots as well. So let me write it. If any day I becoming negative or j becoming negative, what should I return from here, guys? You need to find total number of ways. So if you are reaching any invalid spot, what should you return from there? There is no way. And how do you tell that information? By returning a what value? Tell me. You return what from here? You have reached an invalid spot. So is there any way? That's not a way. You have reached invalid spot. Okay. So you should just come back by getting a value 0 from there. 0, 0. Okay. There is no way, na? So 0. Now, if luckily you go to that lucky spot, you know what that lucky spot? Can anyone tell me? Starting from n minus 1, m minus 1, what is the lucky spot that you want to achieve? The lucky spot is your original source, right? You want to, like, you have starting in backward direction. So that lucky spot is 0, 0. So if you are reaching I0 and J0, if you have reached I0, J0, so what is ways? So you are going to return a 1 from here. See guys, your problem is always totally up to you how do you want to write it, but yeah, I think this is the we should get key. If we are reaching any invalid spot, we should return 0. Otherwise, we should return 1. Okay. Now guys, let's see. Okay. Let's do bato because we have reached the lucky spot. Now guys, without even me drawing the recursion tree here, are there repeated problems? What do you feel? Well, essay, just imagine it in your mind and tell me, are there repeated problems? Okay. Think about it. Suppose you are here, you are making a call here, right? If you are here, you are making a call here. Don't you agree कि 1, 1 is getting called twice and maybe more number of times, right? So yeah, I feel कि things will get repeated. If we are not sure, that's not an issue. We'll just draw the recursion and confirm it. Got the point, guys? Okay? We'll just draw the recursion and confirm it. Let's just see that. Okay. So I will draw the matrix just to explain you कि yeah, we are going in a correct manner. This time I am going to talk about the matrix, this one. ठीक है? So this is the matrix and I'll draw. Okay, so the n given to you is 2. You are given with only n and m. You are not given with any matrix. This is I am drawing just for the sake of understanding. Okay? N is 2 and m is 3, guys. You are given a 2 cross 3 matrix. Okay. Now, like 0th row, first row, 0th column, first column, second column. The point is to come here. Now, first of all, to tell me, your recursion is getting started from which index? Your recursion is getting started from n minus 1, m minus 1. That means from this spot. Okay. So recursion is getting started from 1, 2. Okay. Now guys, see, every time, guys, please, let's focus here. Hai na? Every time, please make 2 calls. One calls to the top neighbor of yours, another call to the left neighbor of yours. Okay. So one call to the top neighbor, another call to the left neighbor. Okay, so let's see that how we are doing this thing. So from 1, 2, if I make the top call, where will I go? I will go to 0, 2, correct? And if I make the left call from here, where will I go? I'll go to 1, 1, correct? Now from 0, 2, guys, you will once again make both of the calls to top. That top is going to be minus 1, 1, minus 1, 2. No, the top of 0, 2 is minus 1, 2. And you will make the left call, that's going to make you go to 0, 1. Perfect. Now similarly, coming to 1, 1, you will make 2 calls. Top call, that will reach you 0, 1. Left call, that will reach you 1, 0. Correct, guys? This is a base case because I has become negative. This is not a base case. So from here also make both of the calls. Top call will make you go minus 1, 1. And left call of yours will make you go to the lucky spot. Am I right? Left call from 0, 1 will make you go to 0, 0. Correct. Now from 0, 1, you will make once again both of the calls. Top call will make you go to minus 1, 1. Left call will make you go to 0, 0. Now from 1, 0 as well, guys, you will make both of the calls. Top call will make you go to 0, 0. Left call will make you go to 1, minus 1. I am just saying simple thing. Just have a look at this recursion diagram, guys. Do you agree? Total number of times you have reached that lucky spot. That is what your answer is. There are 3 ways by which you can reach 0, 0 to 1, 2 or 1, 2 to 0, 0. You can just understand it in any way. So there are 3 ways by which you can go from 0, 0 to 1, 2. Am I correct? Tell me. So yeah, first one is this way, second one is this way, and this is the third way that you have. There are 3 ways by which you can go from 0, 0 to this spot. Got it? Can you see repeated problems? Yeah, there are repeated problems. This is getting repeated. And if you do it on a bigger matrix, or if you do it on a bigger value of n and m, you will see more repetitions. Okay. Now, first of all, I'll just show you how the answers will get calculated. So see, from here, this is a negative base case, so you are returning a 0 from here. Now you'll go here. This is a negative base case, it's returning a 0. This is a base case 0, 0, that returns your value 1. So 0, 1 will return to reach me, there are 1 ways. There is 1 way. So it will return that. Now at 0, 2 is going to return 0 plus 1. It will return 1. Okay. Now you'll go to 1, 1. It will go to here. Now this call is returning a 0. This call returning as 1. So 0, 1, as it returned previously 1 as the answer. So this time also it will return 1 as the answer. Okay, to reach me, there is 1 way. Now you are going to make the call to 1, 0. So I think 1, 0 will also return you 1 only. Perfect, guys. See what 1, 1 is returning. 1, 1 is returning ki there are 2 ways by which you can reach me from 0, 0. Is that a truth, guys? Tell me. You can reach 1, 1 from 0, 0 by using 2 ways? Yes, that's a truth. Correct? You can reach 1, 1 from 0, 0 by 2 ways. Correct. Now that is what it is returning then. 1 plus 1, that means 2. Now finally 1, 2. See guys, my purpose is in how many ways I can reach here. So I asked in how many ways I can reach the above cell. It is returning me 1. Okay. And in how many ways I can reach the left cell of mine. It is returning me 2. So in how many ways you can reach this cell starting from 0, 0, that's going to be 2 plus 1, 3. So the final value that you are returning is a 3. Correct, guys? Makes sense? There are 3 ways by which you can go from 0, 0 to the n-1, m-1 coordinate. And yeah, first of all, is the recursion making sense to you? Correct, guys? Anyone having any issues? Perfect. Okay. Make sense? So this question is about count. And see, guys, we are doing a DP class. So anyway, we need to convert this logic to DP also if possible. You tell me, guys, can we apply DP here? Of course, you can see there are repeated problems. If you do it on a bigger value of n and m, you will see more repetitions. I did it on a small value of n and m. But yeah, bigger value, there will be more repetitions. Okay. That means DP is applicable here. But important thing, if DP is applicable, what size of DP you are going to create this time? Have a look at the problems that you are asking. What is the answer till 1, 2? What is the answer till 0, 2? What is the answer till 1, 2? 1, 1. So what is the size of DP this time? Okay. So size of DP is exactly, it's equivalent. Now you need to create the array. To solve the problem, you haven't created any array. To find the count, you haven't created any 2D array. See, I haven't created any 2D array anywhere. I'm just starting from n-1, m-1 and doing the work. Correct? But now, to apply DP, I'll create a 2D DP. Reason being, look at the problems. What is the answer till 1, 2? What is the answer till 0, 2? What is the answer till 1, 1? What is the answer till 0, 1? What is the answer till 0, 1? What is the answer till 1, 0? That means, yeah, you have started your journey from here. So all these spots are like coming. These spots are only coming as your questions. What is the answer till now? What is the answer till now? So that is the reason, guys, this is the first question of where you are applying the 2D DP. Correct? Okay. So now I am just going to apply the DP part. That's it. Right now, though, it's taking very much time. It's a bad code because from each and every spot, you are just making 2 calls. It's a bad code. But now we are going to optimize it. Right. So let's not discuss the TC part in this one. Let's write the DP thing here first and then we will see what is the TC part now. Okay. So see. First of all, though, I'll just create the DP. Okay. So yeah, once again, like I'm going to create the DP of, I'll just create the DP here. Don't worry, in the last problem, I'll code it up also. Last problem, I'll code it up. Right now, so let's see. Yeah, my bad. DP has to be 2-dimensional this time. Because in your question, there is 2 things. What is the answer till ij? That's why. Okay. Right. Now, first of all, though, create your DP with the correct dimension. DP of n cross m. So, n, m, guys. Right, guys. Now, fill this DP with -1 also, guys. I don't think there is a direct way by which you can fill a 2D DP. So, you need to apply a loop here. You need to travel on this 2D array completely and fill everywhere -1. Okay. That's I'm just writing as comment. Fill DP with -1. Okay. Now, once that is done, you are calling the helper function and whatever it is returning, that's your answer. Now, guys, DP is created. Let's try to apply DP in our recursive problem. So simple. See, just before returning your answer, you are here to calculate in the helper function. What is the answer till ij? How many ways to reach ij starting from 0, 0? Okay. So that's simple. At DP of ij, you will just put the answer that you are going to return. That means a plus b. Correct? And how are you going to use this thing? Simply just before making your calls. So here you will use this thing. Right? You will just simply say ki if DP of ij is not equals to -1. If this spot is solved, there is a value on this spot. Why are you taking the extra work of making the calls? Then just return the answer from DP. Done, guys. This is how we are going to apply it. Simple. Okay, bas, right? Done. Okay, so we have applied in DP. No, it's like I feel that works for a 1D array only. It does not work for a 2D array. Array is not filled. It works for a 1D array only. Okay. Right. Okay, so now coming to this code, can you now think about the TC and SC part? SC I'll write it as your recursive space is also there, but more than the recursion space, the extra space you are taking is of creating your DP. So space complexity is order of n into m. Can you tell me what is the time complexity? How many distinct problems you must be solving? What is your thought on it? how many distinct problems of I comma j you must be solving, right? Think about it. How many distinct problems of I comma j you must be solving? So like you can have a look at it, this example. One, like these are the distinct problems that we have solved, like 1 comma 2, 0 comma 2, 1 comma 1, 0 comma 1. This is the same repeated thing, 1 comma 0, that means this is spot. This is so your base case always, correct? So you must be not hitting it. So are you understanding? You are just solving all the spots of your 2D array. So how many distinct problems you are solving? The size of your 2D array, correct? Okay, see once again, see, have a look at it. Yeah, 1 comma 2 you are solving it, 0 comma 2 you are solving that as well, 1 comma 1 you are solving that as well, 0 comma 1 you are solving 0 comma 1 as well, sorry, 0 comma 1 again it won't get solved because it's already solved, 1 comma 0 you are solving that as well. Now guys, 0 comma 0 is a base case, so for that you will be just returning your answer in a single throw. So it's like the total number of distinct problems solved by you is approximately equals to total number of cells in your matrix, or total number of cells in your n cross m matrix. So that is the reason TC is going to be n cross m, guys, not n plus m. Agreed? Okay, so that will be n into m. Perfect. Makes sense. So like if there are, like suppose if you are imagining this kind of a DP, total number of distinct problems that you must be solving are all these spots only. You must be coming to each and every spot at least once. Am I correct? You must be coming to each and every spot at least once. So that's why it's n into m. Perfect. Okay. Correct, guys? Makes sense? So this will be your TC and SC with the DP when you are applying. Okay. Now without DP, just think about it. Like according to me, it's this Pratik, 2 power n into m without DP. Because from every spot you are just making 2 calls. So there are n into m spots, correct? So it's that much. बहुत ही ज़्यादा है, like exactly like without a DP, guys, if you want to know approximately complexity, that's approximately equals to 2 power n into m. That's very big, very very big. Okay, okay. So please see once again. Like first, if I summarize this question completely, so see, simple. My question was to reach here. So I said, okay, I can reach here by using this spot and this spot only. So just give me total number of ways of reaching here starting from 0, 0 plus total number of ways of reaching here starting from 0, 0. If you sum it up all, you'll get total number of ways reaching here. So that's why I said total number of ways to reach I comma j from 0, 0 is equals to total number of ways reaching I minus 1j plus total number of ways reaching I comma j minus 1. Okay. Now based on this, I wrote my recursion completely. Now in the recursion, from everywhere, from each and every spot of n into m, you are making 2 calls. So that's why a very big complexity is coming in your recursive code. Now you must see this key while drawing your recursive diagram, you have seen repeated problems coming. That means you can apply DP here. Now look at the problem. What is the answer till 1, 2? What is the answer till 1, 0, 2? Answer till 1, 1. So it's like, what is the answer till I comma j? That's why I created a 2D DP this time. So I created a 2D DP, same as that of your n into m length. I filled that DP with minus 1. I made call to helper function. Now, once I have got the answer, what is the number of ways to reach I comma j, I'm storing it at I comma j, a plus b, and then before making my calls, I'm just using this DP. So now this code with the DP is going to be only order of n into m time complexity, because total number of distinct problem you are solving is not more than n into m, guys. Correct? Makes sense. So now it's a very big improvement from your only recursive code to this TP code. Got it, guys? Okay. Now anyone having any issues in this question? Perfect. Okay, so total ways of reaching Ij from 0, 0 is nothing but ways of reaching just the top cell of your cell, top of your, like total number of ways reaching here is number of ways reaching just the top cell of yours plus number of ways reaching just the left cell of yours. Because if we are reaching to the top cell of yours by using 2 ways, those 2 ways can help us reaching you. And if we are reaching just the left cell of yours using 2 ways, those 2 ways also can help us reaching you. So this plus this, guys. These are the total ways reaching this spot. Okay. And once recursion is clear, then you can go on applying DP if that is applicable. Okay, now the next two problems that we are going to solve are very similar to what we just did in this question. Only few changes here and there, and you'll definitely get your next two problems. So those are like the easiest of today's class, because now you know this problem also. Okay. Okay, so it's 10:43 right now. So let's take a break till 10:53, guys. And then we are going to solve next two problems which are very similar to what you have done in this question. Okay, perfect. Till then, if you have any doubt, please tell me. Yeah, Mukul, checking this question. Yeah, we'll do it in today's class. Okay, Mukul. Okay. This is our fourth question. Hai? If you look at the agenda, so yeah, this is our fourth question. Mean some path. Say. Okay. Okay, ठीक है. So I'll be just back then, and then we will start our next two questions. Okay. Okay, ठीक है. Now let's continue with the next question. Okay, so this question is very similar to what we did in the last one. There is only a single change. Same question, count total number of ways to go from 0, 0 to n minus 1, m minus 1. The only change is, if mat of ij is 1, it is a blocked cell. Okay, else it is unblocked. Perfect. So you can't create a way from 0, 0 to n minus 1, m minus 1 by going through blocked cells. Okay, this time matrix is important because you should know which locations are blocked, which are not. Okay, so can you tell me total number of ways by which you can reach 2, 3, guys? Think about it. What will be the total number of ways by which you can reach 2, 3 starting from 0, 0? Okay, yeah, right. And the only two movements are once again R and D. So right and down movement. Okay, guys, try to think about it. In how many total ways you can reach this spot? 3? Yeah, exactly. There are 3 ways. If these cells were unblocked, you could have much more ways than 3, right? Okay, but right now the answer is 3. Let's see how. First way is this one, and correct. Am I drawing it correctly? First way is this one. The second way is, I think, this one. Sorry, my bad. The first way is this one. The second way is this one, and the last but not the least, the last way is this one. Correct, guys? There are 3 ways. Perfect. Okay, now tell me, do I need to change the logic that I have applied in the last question? Or do I need to do any logical change in my recursion that we did last time? Can I just say once again, same thing is happening. In order to reach here, I will just ask in how many ways I can reach here. And similarly, I will ask in how many ways I can reach here. Like I will show you, I'll just remove what I have drawn. I'll ask in how many ways I can reach this spot. That is nothing but equals to 1 only, guys. There is only a single way by which you can reach this spot from 0, 0. Okay, so 1 your answer getting from here. So from here you are getting 1 as the answer. Now you will ask in how many ways you can reach this spot. What is that? 1 and 2. Correct. Okay, so there are 2 ways by which you can reach this spot. The total answer is coming out as 3. Correct. So according to me, like, you don't need to change your logic in this question. Logic has not to be changed. It's going to be same whatever we applied in the last question as well. Now then, what changes are required? To manage this blocking cell, what changes are required, guys? Okay, where should I do the change? If logic is not going to change, where should I do the change then? Okay, take your time. Okay, exactly. Okay, see guys, you tell me simply total number of ways reaching the spot 1, 1. Total number of ways reaching the spot 1, 1. What do you feel? Starting from 0, 0, in how many ways you can reach 1, 1? So you must be willing to say 2, but that's not correct. You know why? Yeah, exactly. Because see guys, this is a blocked cell. Okay, and your question is not dependent on reaching here. Your question is at the end depending on reaching here. That is just a, once you're coming to a blocked cell, you can never move ahead. So can I say coming to a blocked cell means we should just return 0 from there? Correct. Reason being, once you come to a blocked cell, you can never move from here. That means this can never help you in reaching here. Got it? So to the last question, there is no changes. Logically, there will be no changes. Exactly whatever we did in the last question, the DP variant, this, I'm just going to apply the same logic here as well. I'll paste it here. With obviously some few changes. The few changes are, this time you are given the matrix also. Okay, so you are given the matrix also. Int. This 2D array also you are given. Okay, and that is the reason in your calls also you are providing all the 3 things. In your helper function call also you are providing all the 3 things. Similarly, I'll do the changes here as well. Ij and the A matrix is also given to me. Correct. Now in the calls also, I'm going to pass AA. So only one change I'm doing, guys. In the calls, I'm passing this matrix also now. And now only a single change is required, guys. That single change is, if you are ever reaching to a 0th cell, you should return a 0. If you are ever reaching to a blocked cell, you should return a 1 from there. You should return a 0 from there. Okay, there is no ways by which you can move ahead. Okay, so just before this line, I'm going to put up base case. That base case is ki if, of course, if you are going to any invalid cells, the value you should return is 0. Also, if array of I, array of j, like array of I comma j, if that is a blocked cell, if you are ever reaching to a blocked cell, you can just return from there the value 0. Okay, you can just return 0 as the answer. You don't need to do any hard work here. Okay, like the point is, suppose, like if I show you the calls part now, let me show you the calls part, see how the calls will happen. Okay, so starting from 2 comma 3 guys, starting from 2 comma 3, you will make your call to just the top cell of yours, that means 1 comma 3, and just the left cell of yours, that means 2 comma 2. Okay, now from 1 comma 3, you will make both of the calls to the top cell, that is 0 comma 3, to the left cell, that is nothing but 1 comma 2. So the point here I want to share, 0 comma 3 is a cell having 1 on it. So do you agree guys कि when you are sitting here, you are making a call to the above that is storing a value 1 on it, you should just return 0 from here, because you cannot reach this spot via this path. Am I correct? Because there is a blocked cell in this path. Okay, so you don't need to do the hard work ahead of 0 comma 3. As soon as you are reaching 0 comma 3, it's going to return 0. Here I will not help you. This cell is saying कि I won't help you reaching here. Via me you can never reach this spot because I am a blocked cell. Okay, now from 1 comma 2, what will happen if I show you a little bit ahead? So 1 comma 2 is going to make 2 calls, one call to the top cell and one call to the left cell. So top cell is nothing but 0 comma 2 and the left cell is 1 comma 1. See guys, once again, this 1 comma 1 is going to return 0 only. In order to reach the spot 1 comma 2, I can never help. Because you can't go there via a blocked cell. Okay, now here if I write now, these are the spots at which the value 1 is present. Okay, now from I'll just show you one side recursion, not the complete recursion, only the one side recursion, this side, and that will be enough. Now from 0 comma 2, you'll make a call to top, that means minus 1 2. You'll make a call to left, that means 0 comma 1. Okay, 0 comma 1 is this spot guys, it's a safe. So it's going to make both of the calls, one call to top, that means minus 1 1, and one call to the lucky spot, that means 0 comma 0. So see guys, I'm reaching 0 comma 0 only once. So see what is that meaning? The meaning is कि you can reach 2 comma 3 via 1 comma 3 only by a single way, and that is the truth guys, that is the truth. There is only a single way that is helping you reaching here via 1 comma 3. Am I correct? There are no other ways. Perfect. So how your recursion will get fired? Like this call is returning you 0 because this is a blocked cell. Now you'll come here, this is returning you 0 because it is an invalid spot. This is returning a 0 here. Now this is only the thing returning 1. So 0 comma 1 will return a 1. 0 comma 2 is also returning a 1. Now 1 comma 2 from the right sol call, it is receiving a 0. So 1 comma 2 is returning a 1. See guys, is there any truth in it? Tell me. In how many ways you can reach 1 comma 2 using 0 comma 0? From 0 comma 0, in how many ways you can reach 1 comma 2? So this is your 1 comma 2 guys. And starting from 0 0, we have only one way to reach 1 comma 2. And that too via 0 comma 2. Via 0 comma 2, not via 1 comma 1. Correct guys? Okay, so this is the intention. Now finally 1 comma 3 will return 1. So see guys, you can reach 2 comma 3 starting from 0 comma 0, or you can say ki, let's see this spot. 1 comma 3 is returning a 1 answer. So it is saying ki from 0 comma 0 you can reach 1 comma 3 by using only a single way. Tell me, is that a truth statement? You can reach 1 comma 3 by only a single way? Yes, we can. There is only a single way that is helping me to reach 1 comma 3 from 0 0. Correct guys? So do you agree ki logically no change is required, only this thing. First change I did is ki here everywhere I mentioned the matrix now, right, in my calls and everywhere. And the second important change that I did is this space case. If you are hitting an invalid situation, that's obviously you should return 0 from there. If the spot is not invalid but it is containing a 1 value in it, you should return a 0 from there. Blocked cells can never help you. And last but not the least, if it is not valid, not a blocked cell, and you are reaching 0 0, that means from here you can return a 1 value. Correct, guys? Okay, so is that thing making sense? Perfect. It's very similar to what we did in the last question. The only change is the matrix involvement, and the second change is this blocked cell base case. Correct? Okay, and this is how we will be calculating our answers now. Like, it's important, but yeah, matrix, I want to show you the matrix, that's why I draw it here. Otherwise you can draw it here as well. It's fine drawing it here as well. Perfect, guys. Okay. So is this thing making sense? Anyone having any issues in this question? Like, what I feel is, once the previous question is done, this is just what we can say extension to that question. Okay, guys. Now, do you agree? 2, 3 will make the call to right hand side also. 2, 2. Okay. So 2, 3, it's making a call to 2, 2 also. Okay. In how many ways you can reach 2, 2 from 0, 0? So can you tell me what will be the answer? Yeah, recursion will happen here. But in how many ways you can reach 2, 2, guys? From 0, 0. So that's going to be a 2 value. Perfect. There, that's going to be a 2. See, we need to reach 2, 2 from 0, 0. So that's one path this and another path this. Okay. So yeah, that's going to be 2. And finally, 2, 3 will return 3 as the answer. There are 3 ways by which someone can reach me. Got the point? Okay. Anyone having issues? So not a new question, just an extension to the last one. And this is how we can deal with that extension, just a base case. Whenever we are hitting a blocked cell, we should return a 0 from there. Okay. Correct. Like when you are here, top, this cell can never help you calculating the paths because this is a blocked cell. So you cannot come to this spot via this. Okay. So whenever you are hitting a blocked cell, just return a 0 from there. Got it, guys. A quick thumbs up if this is clear. So are you understanding? Okay, I am putting this base case and that's dealing with it. Okay. Like here, if you see 0, 3 and 1, 1 were returning 0, 0. Okay. Right. Now guys, the last question of today's class. Okay. So once again, I feel a very similar question of what we have done. So you can just answer me very quickly what's going to be the logic of this question. Minimum sum path. So till now we were interested in calculating paths. Now I want you find the cost of path also. Okay. So given a 2D matrix filled with the non-negative numbers. Non-negative means 0 and positive. Find the minimum cost path from 0, 0 to n-1, m-1. Once again, the two movements that are allowed to reach this from 0, 0 is the right moment or the down moment. So from every spot, you can either take a out moment or a down moment. Same as that of last two question. You need to find the minimum cost path from 0, 0 to n-1, m-1. Got it, guys? Like, can you help me finding that minimum cost path in the first example? Yeah, please help me. Keep finding the minimum cost path in the first example. What's that? Okay. What is the minimum cost path? Okay, so there are multiple paths. Like if I show you this path is of how much cost? 2 plus 3 plus 5 plus 4 plus 7. So I think it's 21, right? That's very high cost. Can you suggest me some better answer? Okay. So 21627. This path is giving you how much cost, guys? 2 plus 1 are 3, 6, that's 9, 11, 18. I think 18 is the best answer. There is no other path that can give you better answer than 18. You can just try it on. Okay, so let me show you some other paths also, like this one. This path is of how much cost? 2 plus 1, 3, 12, 14, 21. This path is of cost 21. Okay. This path is of how much cost? 10, 14. It is also of 21 cost. Okay. Now if you look at this path, it's of how much cost? And you know, like look at this one. 2 plus 3, 5, 5 plus 6, 11, 11 plus 2, 13, 13 plus 7, 19. This path is of cost, 13 plus 7, 20. This path is of cost 20. Better than the previous two paths that I showed you. But yeah, the best one is this one. This is the minimum cost path. Okay. 2 plus 1 plus 6 plus 2 plus 7. That's just 18. So your answer in this example is going to be 18. Okay. Can you tell me what is the answer here? What is the minimum cost path? The part that's giving you the minimum cost? Exactly. That's who would like to go from here, right? There are very big values, 100 and 200. Similarly, I don't like to go from here as well. Of course, this is the best. Okay, so the best thing is 2 plus 10 plus 1 plus 3. Like that's giving you how much, guys? It's a 17, right? Okay, this is the question. Perfect. Now, guys, why this question is important? Because this will help us to identify the very minute distance between greedy and DP. My only question to you is this: can I become greedy while taking decision? Okay, suppose I start my journey from here. Okay, and you tell me, if I behave greedily, which one to pick now? You are saying just pick only a single thing. So either I can pick the right one or I can pick the down one. What will I pick? If you want to behave greedily, you would like to pick the right one because right one is smaller than the down one. Correct? The point is, as soon as you have picked it, that means you should never go from here. Because that's what is the meaning of greedy is. Just go to a routed path. Don't go on all the ways. Okay. Now the problem is, as soon as you have reached here, guys, now are you understanding? There is no going back. Okay. So your all remaining paths are these many, and they will never give you the best answer possible. Got the point? The best answer possible was via this. Perfect. So the point here is, you can't choose where to go greedily. You can't just do that. Okay. So greedy won't work in this question, guys. You need to look at the possible paths and then find out your answer. Got the point? Because if you are standing here, choose one greedily, that's not a good decision. Because after one, you can either use this path or use this path or use this path, and none of them will give you the minimum cost path. Correct, guys? So greedy won't work here. You need to find out all the possible solutions. Yeah, exactly, Pratik. Okay, greedy cannot be applied in all the questions, right? Now, guys, in this one, tell me, whatever we did in the last two problems, can we just apply the same? What do you feel around it? Socho? Right, I would just like to draw this example, and let's see whatever we have applied in the last question, can't we just do that same thing? Yeah, okay, so see, simple thing. I'll ask, please give me the minimum cost reaching this spot and give me the minimum cost reaching this spot. Let's try to find out. What is the minimum cost reaching this spot 1, 2? Can I say, let's just find out all the possibilities. So 1 is this, 2 plus 3 plus 5 plus 4, I think that's a 14. Okay, another one is this, 2 plus 3 plus 6 plus 4, I think that's a 15. Another one is this, 2 plus 1 plus 6 plus 4. That's how much, guys? That's, I think, a 13. Correct? So can I say yeah, this is the minimum cost by which you can reach the spot 1, 2. Correct? This is the minimum cost. 2 plus 1 plus 6 plus 4, 13 out of all the options. Okay. Now similarly, what is the minimum cost reaching 2, 1? So let's find out that. 2 plus 1 plus 9 plus 2, I think this is 2 plus 1, 3, 12, 14. That's a 14. Okay. 5, 11, 13. That's a 13. Okay. 2 plus 1 plus 6 plus 2. That's very less. That's how much? That's just 11. So do you agree? Minimum cost reaching 2, 1 is nothing but this cost. Now, guys, let's see this. Minimum cost reaching 1, 2 was 2 plus 1 plus 6 plus 4. That's a 13 actually. Correct. Now, minimum cost reaching this spot is 2 plus 1 plus 6 plus 2. That's how much? That's an 11. Now, guys, out of them, pick the minimum one. Which is minimum out of 11 and 13? Obviously 11. So 11 plus u is the answer. Correct? Simple. Right? Okay. So same thing. Like whatever we applied in the last question, same we can apply here as well. No, Mukul, we can't. Like even if you are doing it iteratively, you need to apply recursion. Now you should go on the neighbors to find out the answer. Okay, guys. Right? Okay. So simple strategy. Like if I show you once again what I did, I think that's important. Let's do that. Once you got that idea, then it's all good. Okay. Just give me a second. I'll just draw it a little big also. Let's just remove it now. Why to waste time? Let's grab this. The answer should come out as 18. So see, whatever we applied in last question, we'll apply the same thing. Give me the min cost reaching this spot. Okay, so see, my call is this. Min cost, if I want to find out the answer reaching here, I'll find out the min cost reaching just the top cell of mine. So min cost reaching I minus 1 comma j. Similarly, I will say give me the min cost reaching just the left cell of mine. That means I comma j minus 1. Now I will say कि my answer is nothing but what, guys? Return minimum of a comma b. That is your answer. Is that a truth? No. A comma b plus yourself also. You can't forget to add u. Okay, that is the answer. Correct? So minimum of a comma b plus area of ij, that is what your final answer is going to be. Okay, so let's see that. If I am here to find out the minimum cost reaching 2, 2, I will say please give me the minimum cost reaching here. Okay, so this is the sub problem I am going to ask. Give me the minimum cost reaching here from 0, 0. Let's see what is that. So minimum cost reaching this spot is 2 plus 3 plus 4, 6 plus 4. Out of all the possibilities, this is the minimum cost, guys. 2 plus 3, 5 plus 6. Sorry, plus 6 is 11 plus 4 is 15. This is 15. Now this choice is 14. And finally, this choice is just 13. So this is the best way. To reach 1, 2, the minimum cost that you are going to apply is actually 13. And if I draw the path, this is the path. Correct? Okay. And the cost is 13. The minimum cost reaching here is 13. Similarly, find out the minimum cost reaching just the left cell of yours. Okay. So just the left cell of yours. Now minimum cost reaching here is, let's explore all the options. So 2 plus 3 plus 6 plus 2. That's, I think, that's how much, guys? That's 13, right? Now the other option could be this one. 2 plus 1 plus 9 plus 2. That's, I think once again it's 14, even more. Now the last option is this one. 2, 1, 6, 2. If you look at this, 2 plus 1 plus 6 plus 2, that's just 11. So minimum cost reaching 2, 1 is 11. And via what? Via this thing. Okay. Now, just out of them, pick the minimum. So, minimum cost reaching, the minimum cost of reaching here and there is going to be out of 11 and 13, you will be selecting 11. And that is by which you are going to get your best answer possible. So, the best answer possible is via this 11. Okay. So, via this 11, you will create your best answer possible. Correct, guys? So, your answer is going to be minimum out of your cost of reaching the top cell and the left cell. Okay. And to that, just add your value. So, answer will be 18. Got it, guys? Okay. So, simple. Like logic once again has not changed a lot. The same things we have applied in the last question, we are doing it in the same manner. This time, we are just interested in calculating the cost part. Got it, guys? Anyone having any issues? Perfect. Mukul, then we will just, what if they ask us to reach 4 or 9 at min cost? So we are storing it here, right? Like the minimum cost reaching here is nothing but 13. And the minimum cost reaching here will be stored at dp of 20. So you can use them. Okay. Right. Like in order to get the minimum cost till now, you are getting the minimum cost till each and every step. Then you are able to find your final answer. Okay. Correct, guys. Okay. So based on this idea, let's try writing the code. This time I'll directly include DP part. Okay. And can we just code it up in the ID directly? First I'll write the recursion step and then we'll write the DP thing, because I think logically though whatever is important I wrote it here itself. Okay. So let's write the code and then I'll paste it. Keep code. I'll paste the link here. Okay. Right. So let's try writing it. And let's see, are we getting correct answer or not? I'll just write the same example on ID also. Okay. I don't think we need to import anything. We are just creating a 2D array, so it's fine. Let's create the 2D array. Okay, what was the content? 2, 3, 5. Let's write it. 2, 3, 5. The next row was containing 1, 6, 4. And the final row is containing 9, 2. After working on this example, I'll change it. Okay, to work on some other example. I've created this matrix, and that's it, guys. Now I'll just call the solve function, although see, right, actually see, now I'm the complete owner of this code, so I'll just initialize my DP from here itself, guys. From the main function itself, I'll initialize the DP part. Okay, so I'm just going to call the helper from here. So I'll call the helper, and whatever it is returning, that's what my answer is. So I'll print whatever the helper call is returning. Okay. Right. So to this helper, I'm going to pass a, not needed in Java, but I'll pass n-1, m-1 also to give me the minimum cost reaching n-1, m-1. So n is nothing but total rows and m is nothing but total columns. Correct, guys. Okay. So I will say give me the answer of reaching n-1, m-1 starting from 0, 0. Okay. So if I write it, min cost from 0, 0 to n-1, m-1. This is the question you are asking. Okay. Now, first of all, I'll just write a recursion, test it, then I'll apply DP. Okay. So static int helper, it's receiving the 2D array A and then I comma j. Simple thing. What is the minimum cost reaching I, j? So first of all, and let's name it as min cost, right? In my logic, I named it as min cost. So let's do that name. That's more meaningful name. Now, min cost reaching ij is simple. First of all, find the min cost reaching just the top cell of ij. Okay. So min cost reaching I minus 1 comma j. Similarly, find the min cost of reaching just the left cell of yours. That means I comma j minus 1. Now what your answer is? Your answer is minimum of them a comma b, and just don't forget to add yourself. Okay. Now that's what your answer is. That is what the minimum cost reaching you. Finally, we can return the answer. In this process, if you are ever hitting the invalid spots like I less than 0 or j less than 0, see guys, I started from n-1, m-1, and every time it's like, going backwards. So yeah, negative things I can hit. So if I'm going on I less than 0, j less than 0, guys, what should I return? This is interesting. This question is about minimum. It's not about sum or count. So from an invalid spot, what should I return, guys? Any guesses? Think about it. Should I return 0 or should I return something else? Okay. See, I'll show you. Suppose a small example I'm taking, 2, 3. Some spots are here and 4 is also here. 1, 9, 7, and some spots are here. Like there are some more spots, but I'm not showing it to you. Suppose this is the situation right now. Okay, I am at this particular cell, so I can show you the I value is 0 and the j value is like 1. I'm at this particular cell. Okay, it's going to make its left call. Left call is 0, 0. So left call is going to return what as the answer? Left call will return like, I think, let's make the top call first. Okay, so let's make the top call first. So see, if 0, 1 is making the top call, so do you agree that's an invalid point? Now, suppose if you are returning a 0 from here, suppose, and now you will make the left call. So if it is making the left call is the cell 0, 0. So 0, 0 is going to return its value. That means 2. Now, how are you creating the answer? You are saying to pick minimum out of them and add me to it. Minimum out of them is a spot. Minimum out of them is 0, and that's not even a valid spot. So what are you returning? You are returning minimum out of them and your value, that's a 3. And don't you think it's incorrect? You are saying minimum cost by which you can reach 0, 0 to 0, 1 is 3. That's false statement. Minimum cost reaching 0, 0 to this spot is 5 actually. Correct, guys? So can I say from invalid spots, you should not return 0 because that will make your answer incorrect. Okay, right? So because then the invalid spot zeros is getting considered, which is wrong. So do you agree? From the invalid spot, I should return infinity, so that it's going to be totally ignored. Correct? I am here. Okay, I am here. I'll make the top call. Now that invalid spot is returning me infinity, so A will be infinity. I'll make the left call. That left call is returning me a 2. Now tell me what is minimum out of infinity and 2? Obviously 2. So that's going to be minimum, and now to that just add yourself and you are returning your value correctly. Nice or not, guys? So from the invalid spot, so that it's not getting calculated in the answer, it's totally getting ignored, I should return integer dot max. Okay, I have reached invalid spot, that's why I'm returning a very big value so that it is never going to be considered. Like here, when 3 is making a call to top, infinity is coming from here, and when it is making a call to left, 2 is coming. Now out of infinity and 2, which one will get picked? You are picking minimum, so 2 will get picked, and to that you are just adding your value, so you are returning 5. The cost of reaching 0 1 from 0 0 is 5, and that's the truth. Okay, that's 5 actually, right? Now if you are reaching that lucky spot, I is 0 as well as j is 0, so yeah, you have reached that spot, you can just return its value. Okay, that's it, guys. Okay, so I think this is going to be my recursive code. It should work fine. Let's see, are we getting, for this example, our answer was 18. Let's see, are we getting 18 or not? If recursion is working correctly, then we'll apply DP here. Right now the error we are getting, what is it is saying? Class min cannot be applied to, let's read it. Min cost. Am I using the name separately? What I did? Method min cost in class min cannot be applied to given types. I did some mistake while providing variables. So I'm providing a 2D and here also I should do it now. Right, this is a min cost function receiving 2D array ij. So I should also, while calling min cost, keep a track of that, right? So now it should work. It's giving me 18 as the answer. Suppose if I make 16, if I make this 6 value 16, do you agree now your answer has to be something else? Because previously you were getting 18 out of this 2, 1, like 2, then 1, then this 6, then this 2, then this 7. Now suppose if I make this a 60, now your answer is definitely not this path, something else but not this. So let's run it. Okay. Now my answer is coming out to be 21. Do you agree, guys? This is the best now we have. Okay, 21. I think that 21 is coming out of where? I think 2 plus 1 3 plus 9 12 plus 2 14 plus 7 21. Yeah, correct. So that L kind of shape path. Perfect. So yeah, I think it's working fine. Right. Now I'll change it to original example. Okay. Right, guys. Now once this is done, applying DP is not a big deal. So I'll just create the DP array here. Right. See, you are asking the problem ki what is the min cost till ij. So you need to create a 2D DP here. So 2D DP array created. Before making my call, I'm just going to initialize this DP with the correct dimension and then fill it. Fill DP with -1. I don't know if there is a direct way to fill your 2D in Java, but I think there is not any direct way. So I'm just going to apply the standard loop. So I0, I less than n, I plus plus. Similarly, J0, J less than M, J plus plus. Everywhere in DP of ij, I'm going to put a -1. Okay, guys. So this is what we can apply. Okay, we have initialized the DP and filled it with -1. Now, I'm just going to use the DP. Just before returning my answer, I got the min cost till I comma j. So this is what I'm going to put. At I comma j, I'll just put that answer. And similarly, before making my calls, I'll just use the if DP of ij is not equals to -1, I will just return my DP of ij value. Correct, guys. Now that's it. Let's just run the code now. It should also give me 18. What is the issue? Yeah, your min cost function as well as the main function is static, so it has to be static then. Correct. So now let's run it. Perfect. Once again getting the answer 18. Okay. So is the logic clear, guys? Is the logic of this problem also clear? Right. The only change in this problem is we are calculating min cost path instead of count of paths. Okay. Otherwise, all of the things, the way you are dependent on your sub problems, this thing is same. The way you are calculating your answer is a little different because you are picking minimum out of them. Okay. Now one very quick exercise I want to show. Have you ever tested it out ki by applying DP, is your code behaving efficiently or not? Have you tested it out? Have you done some test? Is it working a little bit better or not? If you haven't, I'll show you how to test it. See, just create a static variable. See how many calls you are making, है ना? ऐसे calls, just create a static variable here. Time you can use, calls also you can use. Okay. Time in millisecond is a little bit changing parameter, so I'll suggest you कि with the help of calls also you can do it. Okay. Now before calling it, initialize this calls variable to 0, guys. I'll show you an interesting thing. Every time you come here, that means you're coming to a function call. So every time you come here, just to do calls plus plus, and especially after this line, just do a calls plus plus. Okay, whenever you are coming to a function. So first line here is after all the base cases calls plus plus. Now once you are done after it, just print what is the value in this calls variable, total calls taken by your function. See, now let's see what is the value coming out. Okay, it's not working. Let's see, run it. Okay, 8 is coming out right now after applying DP. Okay, now I'll just comment out this line, not any other line, but this line ki whenever you come to a function, if the problem is already solved, don't solve it, just return its answer. So as soon as I comment this line, I think the number of calls should grow. Do you agree with the same? Ki now you'll be making more number of calls. Okay, let's run if that is happening or not. Okay, can you see more number of calls are there now? That means you are making more number of calls. Your logic is becoming more time taking. Correct. This is only a small example. If I show it to you on a big example, na, like I add up a lot of fake things here, suppose a lot of fake things, but essay, I'm just doing anything, not very nice values, just anything, so that I can show you on a big matrix also. Okay, 2, 0, 9, 1, something like that. Right? The only thing is every row should have same columns at least. So I'm just checking that. I think it's fine. Okay. Now let's just test it. See. Apply this thing. Kia. If the problem is solved, don't solve it again. Now you should have lesser number of calls. Let's see how many. Okay. So my answer is coming 30. Calls I made is 20. Now let's comment this line out. As soon as you comment this line out, now you are always making all the calls. Okay. Now your calls should be definitely more than 20. Let's see how much. So can you see this marginal gap, guys? For a small example, the gap was very small. But for a big example, the gap is very large. With DP, it was just 20 calls. Without DP, it is 91 calls. Are you realizing? If you do it on a either bigger example, then the marginal gap will be even more. Got the point? Okay. So this is, just a testing thing. Ki, yeah, you can just test ki if your DP solution is actually working efficiently or not. Okay, this is how you can do it. You can just check how many calls you are making before applying DP and after applying DP. Okay, right now I'm just removing this. Okay, so I'm just keeping this thing, and I'll just finally show you is the answer coming out correctly or not. Yeah, this and this also. This also. And I'll just change it to original example that we had. That means only this much part. Okay, so you can just try out this thing in all of the questions we have solved. Right? Now let's run it. The answer should be 18. Yeah, it's coming out. Perfect, guys. Okay. So with that, let's end today's session, guys. Okay. So in today's class, once again, we have gone through some DP problems, especially those problems in which we are creating 2D DP kind of thing. Okay. So now I'm starting the doubt session, guys. If you have any doubts, please stay. If you don't have any doubt, you can drop off. Next class, we will be solving some more problems around DP, and that too. Till now, we were just applying DP in our recursion. That means memoization. That technique is named as memoization, applying DP in your recursion. Next class, we will also see is there any way to apply your DP iteratively? Okay, that way is named as tabulation, guys. But understand, that way is only possible once you have understood the recursion of that problem completely. So recursion is the starting point always. In any DP problem, recursion is the starting point. Okay. There are ways. So till now we have seen memoization. In recursive code we were applying DP. Next class time we will see one more thing. Okay. Yeah, Mukul, I'm just pasting it here. This snippet, what this problem is, min cost path. Okay. I'll just paste this link. I'll pin it here and paste it in your notes also. Okay. Just a second. Okay, so I pasted the code in notes as well. Right. Yeah, Nikhil, like I've sent, like, in our last class itself, just after that, on Wednesday, I sent the request to 2, 3 people, but no response till now. Okay. All the 3 numbers that I got, I shared those information. Please add these numbers to group. I'll once again remind them. Okay, Nikhil. Right. Okay, it's okay. Yeah, Pratik, that's fine actually. That's fine. That's not an issue. But yeah, like the speed partner, like sometimes, see, you should see this thing. Ki, the point is sometimes we need to understand that thing ki what speed interviewer is asking from you. Okay, like see, suppose you are telling them a brute force idea, and if you need to ask them ki, okay, should I go ahead and explain this idea completely, or can I go to the efficient solution now I have some idea how to go an efficient solution. So that might take that might save some time for you, and it is going to matter. Like sometimes there is a time bound thing also. Like even when I take some interviews of TAs, there is a time bound thing. Okay, if I'm giving a one question and that person is taking entire 1 hour in that question, so that means ki okay, speed improvement needs to be worked upon, right? So yeah, that's I think a very genuine feedback, right? So but that's not an issue at all. It's fine. I think ki you must be explaining all and each and every point, so sometimes we need to skip explaining something or explain them at a little bit fast pace. Okay, but that's totally fine. You can definitely work upon this thing. Okay. Mm-hmm. Right. Okay, yeah, exactly. That is, sometimes we need to change the way we explain interviewer to interviewer, right? Like Mukul, see, this problem we are going to apply same logic. It's not a new question, right? Yeah, the only thing is ki you need to store that answer in a 2D list kind of format, and then you need to sort it as well. Matlab ki it's asking you for answers in a particular order. So order thing you need to manage. Logically, it's the same. Okay. Yeah, Pratik. So I'll suggest you ki whatever feedbacks you are getting from your mock interviews, you should definitely work upon them, because these things will happen in real interviews as well. Okay. Right. Okay, Mukul. So logically, you need to apply the same logic in this subset problem. Order pay, you need to figure it out. Sorting might get applied in this question. Right. So please check that once. है ना? मतलब बस implementation में you need to manage the thing कि is the order you are giving is correct or not. They are asking you subsets in a lexicographical order. So grab out all the subsets in a 2D array list, and then you need to apply sorting also. Yeah. And see, Pratik, like the speed thing na is dependent on a lot of factors. Sometimes on the revision thing as well. कि ठीक है, if we have completed our revision, that means we can get a logic or we can get an idea that we've already solved. Suppose same question is being asked. Suppose someone is asking you rainwater trapping problem. So you can solve it very quickly if the ideas are fresh in your mind. Even the brute force as well as the optimized approach. Okay, so that is, the main game changer moment. Ki if someone is asking us a question, we are able to tell them the idea very fastly as well. Okay. Yeah, Abhishek, like depends. We do care about it as well, right? Sometimes you do. Okay. But the main thing is time. But if we can apply space, we should do that as well. Right. Okay, Abhishek. So yeah, it totally depends. Main concern is generally in majority of the cases, main concern is TC. Okay, we should majorly focus on the TC part. But yeah, suppose there are two codes. One code whose TC is order of n, and space complexity is suppose log n, and then there is another code whose TC is order of n, and space complexity is O1. So obviously the second code is a slightly better code. Okay, so when TC of two logics are same and one logic is giving you lesser space, so that logic is a little bit ideal as compared to the other one. Okay, now it depends. See, sometimes there are 3 or 4 ways to solve a question. So, or it depends in the interview also. Ki, okay, like suppose you are telling a way of TC order of n and SC order of n. Now, if you know a way in which you can do this question in just O1 space complexity, you should tell the interviewer. If you don't know, you can just ask, okay, do I need to further improvise it? Maybe they will say no, not needed to further improvise it. Let's move ahead to the next question. So interview is majorly a discussion. Okay, so we should not just to solve the question, okay, let's keep on solving the question. We should keep an interaction with the interviewer. Right? Sometimes they want us to tell something that they want to listen. That is also very important. We are, keeping a discussion with them. Right? Yeah, Pratik, you can start. Like now, we have done almost all of the topics, so you can start doing lead code problems. But the order should be same, Pratik. Assignment, homework, and lead code. You should definitely solve the assignment problems first of all, because that will cover the class content. Yeah, Abhishek, exactly. Like that is what I'm saying. Depends. If they're asking you to improvise it, you should think about some idea of improvising it. If you got that idea, well and good. Otherwise, you can just say, can you give me 1 or 2 small hints around it so that I can proceed? So it's fine. That's not an issue. Okay. Maybe by their hints, you will come up to the final thing. Okay. Yeah, Mukul, like this question that you're asking, I have discussed in this class. I'll show you. I think in DP1. Okay, I'll just see. I've explained that problem in complete detail. No, I don't think here. Maybe in this backtracking class. Yeah, this is. Okay, so that weighted job scheduling problem, it's not properly greedy, Mukul. It's a combination of greedy plus TP. So I've discussed this in backtracking class doubt session. Okay, right? So it's a long problem actually. So you can just watch it from here. Okay, this was our final time complexity coming. O square mein we did it finally. Okay. So in the backtrackings, doubt session recording, you can just refer that part. Yeah, Abhishek, they give us interviews in it depends on the interviewer also, but in most of the cases, they give us hints. If we ask them, they give us. Okay. And that's not a bad thing. Okay. It's totally fine to ask for hints. Like whenever you feel stuck, okay, no ideas are coming, you can always ask for hints. At least you will proceed more in that question. Right. Okay, okay. So yeah, guys, with that, let's end the session. In the next class, we will continue with the more DP questions, and we will do a very important group in next class, that is knapsack. In greedy, we did unbounded knapsack. Okay. In the next class, sorry, my bad. In greedy, we did fractional knapsack. In the next class, we will do some more variation of knapsack problems. Okay. Yeah, like see, Mukul, this is in the interview also you are asking about. Okay. In the interview, sometimes question is not understandable. Okay. See, first of all, we should try reading it thrice, 4th time. We should not just by reading the problem in 1 minute say, ask the interviewer, please explain. That shows, a kind of losing upon ki theek hai, I'm not able to understand, you explain me, right? So we should try sometime to understand the problem. If some part are ambiguous or not understandable, then you can ask, okay, I'm not clear ki is this part explaining this, am I correct in understanding it? So that's more a nice way to approach ki theek hai. See, what happens is, chalo, you are giving me one question. If I tell you ki I'm not able to understand, you explain it. So that's give a wrong impression. Okay. So instead of that, I should try understanding it, and then whatever part I'm not understanding, I should ask that part only. Got it? Right. Okay. So like these small things matters sometimes, but don't worry. Okay, you'll master this. See, you will give a lot of mock interviews, and then before giving the final interview, the real interviews, you'll be well prepared, guys. So don't worry. Okay, like just learn, from your mistakes. Whatever mistakes you are doing in mocks, we should not repeat them in the real interviews. Okay. Correct. Okay, okay. Okay, with that, now I'm ending the session, guys. है ना? I'll see you all in the next class. Okay, take care, everyone. I'll just upload the notes. Okay, good night. Bye bye.